Welcome to part 2 of my new series to design my own printer, or at least attempt to design my own printer. Yeah, basically I couldn't hold myself, so I worked a little bit during the week on what we did last stream, which was the XY joint. We checked that everything is working. Yeah, seems good. I think we're on now. Cool. Yeah, so basically I worked a little bit on the XY joint. I tried not to, but it was very hard. I'm quite excited for this project. So basically, just to start, let me just show you where we are at the moment. And there are also like quite a lot of goodies that arrived this week. Unfortunately, not all we need to assemble the tool had, so we can't do that today. But yeah, let's just quickly check out what we have. So, yeah, so basically this is more or less what we had last stream, or like more or less this is what we had, right? This was the XY joint basically, where like the two Y-axis went through here, and then we had like one X-axis on top and bottom. And basically this would sit here more or less. And the print head later will be here in the middle. So basically this is what we had, and I changed. It looks different, but it's actually not that different. The main change I made is that we only have one Y rod, like we don't have the two top and bottom anymore, we only have one on top. The reason is that like we don't need it, I think, because we have left and right already, so this is like already like defined, like you can't rotate it in any way, shape, or form, like this is enough. And the main problem with two is basically you have four and they need to be like perfectly parallel, otherwise like it locks up when you move it back and forth. So yeah, that's why we only have one on each side now. The other thing is that I then also moved the two X-axis beams, which were like on top of each other before. They're now like next to each other. We need two, because otherwise, you know, one like isn't enough, like it can't just rotate. We don't want our printer to rotate. So we need two. But then basically, yeah, there's not like a good spot anymore on the bottom to attach it, so here we go. Oh yeah, the other problem with this setup was basically, if we would have like installed the tool head later, right? Just like from the way this is mounted, like this is the Bowden version of the mini stealth burner. Like this comes from the Boron V0 repository, basically. Just stole it from there. But basically, like it would more or less be mounted in this position. And the problem with that is that something is odd with my OBS today. Here we go. Okay. The problem is basically, you see like the bottom rod would be below the print surface, so this would not work, right? Because basically the print surface and its bottom rod would like collide, so it doesn't work. So the second X needed to move to the top. Because now like on the new setup, it will look something like this. So there's enough space between the print surface and the rod. Yeah, so that's basically the changes. Actually, like, totally forgot. I have one printed. Because these are both prototypes, these are not the final ones. Just so we have something to assemble today. I have the final version, which you can see here in Fusion. This is the final version. It looks almost the same. It's a tiny bit different from spacing and everything. We can assemble it. I also have printed all the rollers and everything, so we can assemble one of them. I think I have the right one to be assembled. Oh no, the left one to be assembled, and the right one we will keep this one for now. I just don't want to reprint that because, yeah, this won't be the final version. So I just try to minimize how much stuff I print. Yeah, so basically that's for a little bit later. My plan, oh actually before we start doing anything, let's also quickly check out what was in the mailbox. So basically, I think the most cool thing is we got the hot end, which we'll use. This is the Creal B10 hot end. The interesting part is basically this entire assembly plus this bag with 5 extra nozzles plus the nozzle that's on there, and we also have a coupler for the extruder. Like this entire thing is like €4/$4, so it's like super cheap. And it also like benefit is it runs on 12 volt. So our stepper motors we use are also 12 volts. So that's an obvious pick. And it comes with everything we need for having like a hot end, basically. So I was in a mailbox, and it looks actually quite nice. Like, I mean, whoever had the Ender 3 or Creality 10 or something like that knows the hot end, right? It's like the original Creality hot end, basically. Nothing special. Like, it's Bowden line hot end, so the Bowden tube goes all the way to the bottom. But besides that, I think it's fine. It will do the job. Like, won't be the weak spot. Then yeah, we got two little tiny fans. We need one for the print head. So if you have the print heads, they basically, one goes in here to the front. That's our hot end fan, basically. And the second one, I mean, they were like super cheap, so I just got two. I think the second one we will just need or like use for cooling the electronics a bit. So that's that. Then we have end stop switches, which technically you could just use like a simple switch, right? But these are the end stop switches that are also like coming from the Ender 3. They're also like dirt cheap. They're like 30 cents for one of them. We have 3 in total. Yeah, so these will just be used for like XYZ and stuff. I thought it would be fine or like nice to use those because like you can screw them directly and you have like a plug you can like unplug. So it's a bit nicer than just a bare switch. So no soldering involved. I think that's a clear benefit. Then yeah, quite boring. Power, plug. Actually not sure if we will need them. I think we can optimize them out. Like these are the pulleys for the motors. So most likely we will not need them, but we have them in case we do. Then yeah, also like quite standard, just like the standard yellow bed springs. Nothing special. And then like the cheapest belts ever. I'll leave them tied up for now. But yeah, they're like quite shit. Is the other way to say that. Like it's not a nice thing. They don't smell, so it's good. But yeah, besides that, it's just like a belt. Nothing special, but it's definitely not like the higher quality that you would see. Like, you know, like the brown belts you usually see on printers. Like these are not those, for sure. So yeah, that's kind of like what we have already. Unfortunately, I did not get the side fans yet. They most likely will be arriving tomorrow. So it's a bit of a shame. Because if we would have them, we could have put together the hot end. So now we have to wait until next week for that. But I guess now we have something to look forward to. Cool. So then my plan. So today I want to work on the tool head or slash a tool head mount. And I want to work on the front idlers. So maybe just to visualize that. Let me just quickly open the V0 assembly. Just a second. There we go. So if you look at this like beautiful V0, so what we will work on today it's basically like we have this XY joint here, right? This part we already have. So now we need to mount this tool head somehow to this, like for us it's like 2 rods, right? So this is the one part we will do today. We will try to design something that basically encapsulates those 2 linear bearings and then offers like a mounting point where you can mount the tool head to. So that's one part. And then basically I will just design it now basically. I have 2 printers ready, so we can print on stream. Hopefully it's like a small part. I think it will be. And then while we are waiting for the printers to be done, we can do 2 things. We can work on the front idlers, which is this one here. That's the one part. But we can also put together this XY joint in the final form. So I can a little bit like walk through the design process there maybe, and we have something to build. Yeah, and that's basically the plan. So ideally today we will have the X-axis, like the tool head mount, and the front idlers. And next time we can basically then assemble the entire tool head. And depending, yeah, it's then a bit bigger part. Like next time we will work on the motor mounts then. But I don't think they're like small enough to print on stream. Might take like 2 hours to print one of those. So yeah, but then basically next time we can work on the motor mounts. Cool. Then let me check. So yeah, let's start with Fusion, I guess. Let's quickly jump to our project. Let's keep the V0 assembly open. So kind of like how I try to organize that. It's the first time I do something like that, so this might be like a stupid decision, might be a good decision, I don't know. Like we'll figure out at some point. But I try to have like all the different components, like the major like building blocks, basically the sub-assemblies in one separate file, just like to keep the files small. And then like we have this like one main file basically where we assemble everything together. So you see here on the side we have this roller stack, which is like this part here. We have like already 4 of them. And then the XY joint we have 1, 2. That's just like you don't see this behind the. There's the second one. So it's just a mirror basically each side. Move it a little bit closer. And then now we will work on this middle section here. So let's just start by making. Oh, that's not what I wanted, but let's make a new file. And let's call it toolhead mount. Save. Oh. Tall head. Let's fix it. So, and then the other thing I start doing is like I have this parameters file, which contains all the different parameters, like the sizing of the rods and things like that. So the first thing we always have to do is like insert derive, and then we need to select this parameters thingy. And then the only important part is to check the favorites box, and we can start off. So I think the smartest part is to just build like the mounting structure. So basically we need two raw, or like maybe not even. Let's just do the following. I have this imports here, which is like all the parts we're gonna use like externally. So let's just insert this like bearing, and let's just work around that. I think the first one doesn't really matter. We can just plop it anywhere. Then we just copy it, because we have 2, right? Now the important part is I have this one parameter. Yeah, you have all those parameters here now. And there's this one which is X-rod spacing. Let's just import all the ones we're gonna need anyways. Like if you put them as a favorite, like they're basically imported. Let's see what else we need. Yeah. Okay, so let's put them together. So we have this one, and this one, and we know that the Y offset is the X rod spacing. Okay, so this is now exactly how they will be in the final thing. What board? I'm using a used Ender 3 main board, just to keep everything simple and cheap. Yeah, like technically, like the Ender 3 main boards are quite expensive, right? Like if you buy them new. But if you look on eBay, like there's so many people selling like used Ender 3 main boards for like 10, 15 euros or dollars. So my idea was like to just use one of those because it's just, yeah, the cheapest, and it's just like standard board, so you will have no problem like flashing firmware, whether you want to use Marlin or a Clipper. So yeah, the idea is to have the Ender 3 main board just as like a used component. Cool. Yeah, and I guess let's just build something to like encapsulate that. And then in the end, maybe let's also do that right away. So I took this part from the V0. So my idea is basically to use the same tool head mount as the V0. So basically the mini stealth burner fits on that printer. Yeah, that's the main reason. So we don't have to design our own tool head, which I think is really important. Or not important, but like useful. For some reason my Fusion is really laggy. Might be my mouse. Yeah, so basically we can just mount like standard tool heads to it. And also the benefit is like, depending what hot end you have, like I'm using this like cheap as Creality CR10 hot end. But if you have something else, right, there are like so many like hot end mounts already for the system. So I think it's quite good. So basically how this mounts in the real is the wrong word, but here in the V0.1, let's quickly remove the mini stealth burner. So you have this like linear rail here, and it mounts to those 4 mounting holes here. The problem is for us, the bearing is underneath, so we can't really drill into that. And secondly, this is M2. And I try to keep the hardware as simple as possible, so I try to use like 2 or 3 different screw types at most. So we will need to modify that. So that's M3, and then yeah, you see like those 4 holes would basically directly go into the bearing, or we like put it like way high, but it's also not nice. So let's just maybe start by just creating a component and then just make a box around those 2. Let's just call that tool, or yeah, let's just call that how do we call it? Let's just call it mount. So let's just do the following. Let's just project those 2. Maybe it should start with like, no, it's like my Fusion is really laggy. Something it doesn't like. I made an update today. Maybe that was not a smart idea. Hi there, Jonas. So wait. So basically I'm just like making one that's like directly encircling it, and then I can use this offset. I don't like how thick this needs to be. Let's just go with like 2 millimeters. It's quite a wide part, so it should be fine. By the way, the chat box is clipping the latest messages a bit. Not sure if it's intended. No, it's not intended, and I'm trying to fix that since weeks. And every time I fix it, and it comes back. And also I have like, today it's like absolute horrible day for like all technology things. OBS, like the streaming software, also has some issues. I can't open certain windows. So it's not going well. Let me see if I can fix that for you. Well, now it's way too high, but let's maybe go with the middle. See, close. No, now it's not. I see Simon wrote something, but it's not showing on screen. Aye. Okay, let's just go with the it's somewhere floating in the middle option. I'm building a bastion at the moment. You should look at the toolhead of that. I'm not quite sure what the bastion is. Tell me, what am I missing? But yeah, like the idea is to use the Bowden toolhead of the V0. Or like if you fancy, you can also use a direct drive later. But just like for parts cost, like the Bowden is a bit cheaper actually. Because we can use those, I don't have it here now, but we can use those like super cheap steppers. But I don't see a way of really fitting that on the mini stealth burner. And I try to not design my own toolhead for now. Yeah, everything I do in Fusion has like a 1 second delay sometimes. I think also like what we did with the other part was quite smart, where we don't use a circle, but we use like 45-degree angles just to like clamp it into place a bit. So let's try this here as well. Formerly Rook 180. Oh, yeah, the Rook is also interesting, right? Because like it has only printed parts basically. It's not dissimilar from what I do, because I also will print, I think, some parts that are actually like not like properly bought for the Rook. Because for example, like the I forget words sometimes. Here, the here, this one. Those are also printed in my case. Man. Pulley, thank you. The pulleys will also be printed. But I was looking at the Rook, and we most likely will use the same Z mechanism for the bed as the Rook, like the belt with that just goes around the motor. Because I think that's like really clever solution, and we don't need like a lead screw or something, and you need to buy belts anyways. I'm trying to like limit things you need to buy, because like if you try to make it like really cheap, like every extra item you buy, like maybe it's like 2-3 euros, but it really adds up super quickly. Let's also do the following. Instead of making this like all round, let's just build one half and then we can mirror everything over. I think that's smarter. So let's just... I'm not sure if you can see that, but like I draw a line, it's like... Not sure if I should restart Fusion quickly. This is quite a pain to use this way. Okay. And let's use a circular pattern to like get this edge around. Oh, but actually like we don't have any tolerances right now. So let's actually do it like this. And I I'm missing the parameter for tolerance. I have like this shared tolerance parameter. So you can just change it in one place. Here, tolerance. We just have this minus tolerance. And then also for like this box, we just say minus tolerance. Plus tolerance. Here we go. And then we can just use a circular pattern. And then the sketch is already plenty complex. We use the center point. And then we need, of course, 4. And then we have like our shape, I think. So the only thing we need to check is in here. I think we can just connect those two. And then like my goal is like something that we can slice in the middle basically and print laying down. Okay, then let's just extrude that. So I have to do it in 2 steps. Hi Neo. It uses the Dragon Burner tool head. Yeah, you can buy 1 Dragon Burner tool head for the like entire part price I'm aiming for. We're going to use like my goal is really to keep it real cheap, just like as a fun thing, because like there are enough printers on the market in a certain sense. So I try to be like a little bit creative in what to do. So we're gonna use this. This is like what I'm aiming for. This is the hot end of a CR10. And you can buy those on AliExpress exactly like this, like with the wiring and the bone tube and everything. And it comes with a little goodie bag as well with like 5 extra nozzles and importantly the coupler for the extruder. And this entire set runs you like €4 or like $4. Yeah, that's basically the only hot end we can afford with like a budget of like 100. It's really like, I mentioned it before, but every cent basically, it really adds up quickly. So, just extrude that. We need to do it on both sides. I'm not sure if the sketch is in the center. Okay, let me quickly restart Fusion. That is not serviceable. Yes, no, €100. That's the goal. There's asterisks though. It doesn't include the filament you need to print the parts, because if you add the filament, like, it will be even harder to complete. So this is not aiming to be like a high-end machine. Instead, like it's really like, yeah, it's supposed to be cheap, dirt cheap. So it's more about like how cheap can we make it. Just like quickly show, like last stream we worked on the motor just like as a proof of concept. So that's not the main board we're going to use, but I just use it for testing. But these are the motors we're using. So we don't use the normal NEMA stepper motors because they're way too expensive. The things like one NEMA stepper is like the cheapest one you can find is like €5, which is cheap. But if you buy 4 of them, like 20, like a quarter of your entire budget is gone. These are like €1 per piece. They are technically 5 volt, but last stream we modded this one to be 12 volt. And also normally they have 5 wires and you can't use them with the normal mainboards. And as you can see, we only have 4 wires left. So part of the mod was basically removing the 5th wire and proving that we can drive this like stepper motor with the normal printer mainboard. So yeah, that's basically a little bit of like a challenge, just to make it really cheap. I think Rollo uses Bamboo Lab hot end, which is a little more expensive, but still good value for money. Yeah, definitely. I think the Bamboo Lab, quite a lot of people started using them in like random printers. Because they are so cheap. I mean, I'm pretty sure that Bamboo Lab sells them below their manufacturing price or like close to the manufacturing price. But then basically, yeah, you benefit from Bamboo Lab kind of like subsidizing the hot end. But I think they're still like 25-ish euros or something. Like they're cheap, but they're too expensive for us. I'm still restarting Fusion, or attempt to. And see, now it's closing. Like something's wrong with Fusion. Like it's hyper slow. But yeah, so we use this hot end. We use the super cheap steppers. The main board. And Romecha already asked about the main board. So my plan, or like my idea, is to use a used Ender 3 main board, because you get them like on the used market, you get them for like next to nothing. And it's good enough for what we want to do. And then basically another challenge is we don't have enough money for a heated bed, of course, because heated bed, like the cheapest way you can make it is like another like 30-ish euros. So we will not have a heated bed. But my idea is to make everything in a way that you can swap out parts. So let's say like you want to spend like 150 euros, you can like throw in a heated bed. So just like I'm trying to stick to standard parts, but then like replace them with like printed alternatives. It prints parts in the end with good enough quality, and it seems to be more the project than to me that the project will be a success. Let's see. I mean, like the quality is a question. Quality, I think, mainly depends on the motion system for us. Again, like we need to keep stuff cheap. So the motion system we are using are those like aluminium rods from the hardware store. So you get 1 meter of this rod for I think like 3 euros. And we built the entire printer from these rods. And then you see like these are like linear bearings. We printed them. You can replace them with real ones, but I actually saw people using this printed variant on their Prusa machines. So Simi is quite good. So yeah, that's kind of the motion system. And I think this will mainly dictate our print quality in a certain sense, like how rigid can we build a printer. Worst case, it's super slow. But again, like I'm trying to design the printer in a way that you can switch parts out. So I'm very bad at multitasking, by the way. So although we use those like cheap steppers, what I'm trying to do is I will try to build the printer to accept normal NEMA 17 steppers. Because basically one of the upgrade options is, instead of like these like janky nonsense steppers, basically you can just use like a normal NEMA 17 stepper. Then instead of like €1 you pay 5 per stepper, which blows the 100 euro budget. But still you then have like a much more capable machine. But it really depends a bit on how sturdy our motion system will be in the end. And that's like my main concern, is like that those rods are not really suitable to be used in a 3D printer. So let's see, we have restarted Fusion. Let's see if it now wants to cooperate a bit better. So yeah, we're working now on the tool head mount. I don't think this helped a lot. Oh wait, I need to select this edge here. Yeah, we have the right one. Okay, so basically this is like the most simple case we can have. Oh wait, we didn't want to extrude. Ah wait, there's a leakage somewhere. Yeah, see those like dots, they don't connect to the line there. We have to fix that. So basically we don't want to have it round, we just want to have this like square octagon shape basically. Let's actually just do the following. It's a bit of a hack, but we just moved it out a bit more. Because basically it's enough if we connect it on 4 sides, right? If we connect it closely on top, left, right, bottom, this is good enough. So you can just move it out here a bit, and now we should be able to unselect that. So this is kind of what we want. Although I'm a bit concerned, this is a bit too big here. I use IGOS bearings myself, did not print them, but still plastic in the end. Worked fine. Yeah, I mean, it's kind of the same. Although, like, if you buy the plastic bearings, like, I think they use way, like, harder plastic, like PEEK or stuff like that. So, not quite the same. But it's actually also, like, the linear bearings are super cheap. They're super cheap. So, technically, you can also go out and just buy the linear bearings. Like, I think you get like the linear, like the real like metal linear bearings with the balls and everything, like the normal ones. I actually ordered some. I have them en route. You get them for, I don't know, like also like less than €1 per piece. And it's most definitely not what we want to extrude. Here we go. Now it looks good. Let's see if this is tight enough, but I think it will be. Okay, then we also need to somewhat constrain it from front and back, I think. Not super necessary, but let's yeah, it's like still like horrible. Like, I don't know what's up here. It's really hard to control it. So let's also add something on front and back to enclose it. And oh, I already saw, already made a mistake. No, it's fine. The sketch, I was wondering if the sketch is here. Let's also name that. Just call it base. No. Oh wait, we also extruded the center. We don't need to extrude that. Okay, let's quickly. So we want those 4 and this around, and then this little sliver here. Okay. Just add a second sketch here on top. And I think what we did for the other one is we took this one, the center circle, and then we just set tolerance times 4. And then we can just extrude this part and this part. Now the question is, like, we kind of need to screw into stuff, right? So like from the top, like we can screw in this section here. On front here might be a bit tight. So we need to kind of have enough space, like on the front side, basically. So let's just go with 8. Oh, not minus. And then I think this is still compact enough. I mean, what's the width now? If we would go with that, yeah, it's really hard to control. Right, let me quickly check if there's anything like running that's not supposed to be running. No. Seemingly it's just a bad day for my machine. Okay, let's also quickly do the following. Before we do anything, let's also just create a plane like for the mid-center. Hi there, Alex. When I look at this, I'm asking myself why you are not printing the bearings in a hexagon shape on the outside as well. Yes, I mean I could do that, but I try to keep everything like kind of standard, right? So if you see like I'm modeling here, this is like the real bearing, right? Like the real metal one. Technically, it's not the printed one. So my idea is like that you can swap out parts. So let's say like, also for me, let's say this doesn't work, like I can't print the bearings, they wear out like way too quick or whatever, then we can always swap in the real bearings because like they are the same dimensions. That's my idea basically. Just to be able to like swap out parts as we desire or go. So you basically can up and downgrade. Whatever you want. Like for example, like here, like the cheapest version would be like the printed bearings, but you can also swap in like the purchased bearings. Or the cheapest version would be like we 3D print the bed, but then you can also upgrade to like aluminum CNC machine bed. You know, it's just like you can customize the machine a bit. But you could still change your print bearings. Yeah, definitely. I also printed some spares already. I think we need 6 in total, like 2 for X, 2 for Y, and 2 for Z. Now I'm not quite sure who brought up the Rook. Simon. But yeah, like the Rook also has like the bearings for the printed bed, right? Also the bed runs on the rods. We will do the exact same thing. The only thing that I was like wondering, and that would be like more like a cut challenge. So this part here, like I didn't want to cut the rods like too short. This actually would be enough distance to have the Ender 3 size bed, like a 220 by 220 bed. So the real one would be shorter. Like my goal was a 120 by 120 bed. But then I was wondering, like technically, it's only about how long you cut the rod. So technically, we can also just design additional print bed mount later to allow like larger beds. So that would be like kind of a side quest at the end. Okay, back to our poor fusion here. Yeah, it's struggling. Okay, so that means basically let's already preserve. Oh, that's not what I wanted. Let's just decide arbitrarily where we mount stuff. I brought this in here. Yeah, it's horribly slow. So just like as a size reference. So this is kind of like what we're looking at. This is the tool head mount we want to use. So this kind of goes something like here. Well, way down, but maybe. We'll do it later properly, but something like this, right? Oops. Let me just quickly put this here. So this is kind of, it's not quite centered. But then basically my idea would be to move the mounting holes out to the side here, that they're left and right of linear bearing. So basically this holds everything then together. And I think we would need a little bit more space here for sure, right? I mean, it should be fine. Like there are just like those like mounting holes on the back. Yeah, let's add a little bit more. Let's just make it 10 instead of 8. Just so we have like a bit more space. Now there's like plenty space to put a heated insert. Then the other question is always like, what hardware can we use? Just like that we already keep that in mind. So the total height here at the moment is 19 millimeters. So at the moment we use 12 and 25 millimeter screws. So if we want to stick with this, we need to basically add 6 millimeters of length somewhere, right? I mean, the other option would be to have the... No, we can use the 12. Like if we split this vertically later, like we split along this axis here, then basically we have 19 divided by 2 is 9.5. And then we would have like... no, it's a tad too long. Okay, let's see. We'll figure out the screws later. It's most likely we will need a 16, but I don't want to add like more different like screw types. So it's a bit a bit a challenge to keep everything as simple as possible. Okay, but then let's just start mirroring stuff. Yeah, revert. And we can also like go back before we have this. So basically this extrude, this addition, we mirror around the center, so we have it on both sides. And then we can just mirror the entire body. If I can rotate it around here. And yay, this will be kind of like the base we work on. Then I would suggest let's try to find some mounting positions and how we like separate that. And then we can start removing material, right? Like this is kind of like a box. We don't want a box. So let's make it a little bit more pretty. But before we do so, let's make sure that we can print that. Or like put it together. This is 4.7 millimeters, which is not quite enough for heat inserts, right? So we most likely have to add a bit more material front and back. And this is 6.4, this would be just enough to add a heated insert. But then the question is, so my idea was to have the heated insert in the center. But if it's in the center, we need more space. We don't have space in the center, but we don't necessarily have to put a heated insert in the center. But we have 19 in length, which is 6 millimeters short, right? I mean, it would be nice to have the heated inserts on the bottom. Let's just plan with that for now. And also let's do the following. Before we start mirroring stuff, let's put the ironic. Let's put a mounting hole just here. Yeah, horrible stuff. So this is kind of like the space we have for the mounting hole, right? So let's just center. Center hole around that. And then we need 3 circles. We need one, the screw diameter, which is like 3.3. I actually might increase it to 3.4. Because I saw like the Voron files all use 3.4. Haven't joined one of your streams in a while. Well, welcome back. Then the screw head diameter. And oh, what I'm doing here makes no sense, by the way. Well, let's quickly add the heated insert diameter. So these are always the 3 circles we need, like one for a screw head, one for a screw, and one for a heated insert. But I realized that it makes no sense to put it through here because we go straight through the opening for the rod. But this gives us like a rough idea how much space we need on front, right? So we definitely need to extend the part a bit to make space. A bit unfortunate, but I mean, the other option, unless you already ordered the bearings, I would recommend going with RJ4JP dry-in bearings instead of LM8UU bearings. It's usually a lot quieter. If it's on Z, it shouldn't matter much. I have no clue what those bearings are. Let's quickly check that. RJ4JP. But actually, like the ones I have at the moment are 3D printed. So that's most likely quite comparable to those. The question is, do they have different sizes? Or are they the same size? Because if the outer diameter is the same, like it doesn't really matter. But it's also what you mentioned, right? Oh yeah, it says here. So it would be... Would be the top one or the bottom one here. So it's 15.2. And quickly compare it. What I have here. Now we quickly just compare with like the size of the metal ones. But yeah, I saw those. Oh, they're 24. So the metal ones are bigger. Okay, but that's an interesting thing, like... I see here. These are both? So I assume you can just get them also in the same size. That would be my assumption. Okay, that's an interesting thing. Like I looked for linear bearings and I was just assuming that these were the same. It's, by the way, like a really cheap price. 15,000 euros for bearing. But yeah, like for the beginning, like I am going to have like printed ones anyways. So let's see. So we kind of need to, yeah, like when I try to move it, it's like really like sluggish. Horrible. Let's just go to our initial sketch. Yeah. I will clean it up later, but let's just extend it. Let's just quickly extend it. Let's just say we need... Let's just measure here from the inner side. Let's just say like 4.7 is the thread insert, right? It's an insert diameter. Let's just add 4 millimeters, which makes this quite long. I don't think there's another way to do that, because we kind of have to put our heat insert somewhere. Maybe let's try to keep it a little bit like shorter for now. And let's just say we only do 3. It's a bit better. And then we can remove this here. And attach this down here. Okay, then let's start with the screw hole. I'm in the wrong. I didn't enable the component after I reopened the file. Okay, easy fix. So let's really do that. Let's put the screw through here. Then on top we also have the screw head height. And then for the bottom, it's not a question. Like, do we really want to have the screw through the entire thing? Then we need to add 6 more millimeters of height. Or do we manage with the shorter 12 millimeter screws? But let's plan with the longer ones. So let's do it from here and then this should give us like 1 mounting point. Yes, they come in similar sizes. It's just the dryland bearings don't require grease or anything, and also don't have the noise that comes from the metal balls in the metal bearings. Yeah, of course. Like I'm pretty sure it's smoother or like more silent. But the question is like, would it be such an upgrade compared to the printed ones? I mean, most likely plastic from the pre-made ones is better or better suited. But then given that this is like not like a high performance system, maybe the printed ones are already good enough because they're really smooth. They run really well and they don't have like tons of play. Like it's really minimal. And if you put 2 together, it might be good enough actually to just print them. Like that's just my primary primary plan at the moment. Hi, Francisco. Also holding the bearings, print parts, I think the way the Warren Legacy does it, it's good. They use a hexagon, circumside. Yeah, that's the same what I do. You can't see it right now. Let's inspect section. This is what I do. It's not a hex, it's an octagon. But basically you have tight tolerances on the slopes and then like more space on the vertical. So you have like 4 points where it's like squeezed together. I'm pretty sure it's the same what the Voron Legacy does. Or they have fillets here, you mean, like on this corner. Because like I printed them without the fillets and worked quite well. Like this worked quite well because like it had 4 contact points and like really like squeezes in the bearing without like any like print tolerances like playing too much of a role. Because like, if you print like the half circle, like your tolerances need to be kind of like perfect, otherwise you create pressure on the part if the bearing is too big or it's like sitting loose. Are you going to put it in the bearings while printing, like pause and put? No. We're not done yet. This will be like sliced. It will be two parts basically put together like a sandwich in the end stadium. That was at least the plan. So if Fusion allows us to do so. Come on. So now basically we just have to like slice the body in the center. So let's actually quickly do that. Let's just make a mid plane here, and then we say split body, and then split. Yep. Why does it keep activating the top component? Split body. Okay. So that's basically like a plan, and then you have like the 4 screws in the corners holding it together. It's quite boxy, so I'm trying to, to make it a bit more pretty. I mean, the other option now for the mounting part, right? I'm still trying to figure out how to best mount this tool head on. Let's actually also just quickly do a joint here. Let's just take the center point here and put it on the center here. Just so that we see like kind of what we are aiming for. Okay, so that's kind of like quite big. So what we can do, because now basically the front 2 holes, like technically like we can keep them as they are, right? Because there's enough space. This is, by the way, like the V0 part. Like I'm trying to reuse the V0 part, I can use the V0 tool heads. Got to go have a class. Enjoy your class, Rivonic. Cool. Then I'm not quite sure what's up with Fusion. It's really no fun to use. Then basically we need to modify this part. So what I thought about doing was actually like to move all 4 holes out. What we can try, maybe that would even be nicer, is to combine these holes and those mounting holes that like they are the same screw going through. Let's quickly check. So from here, where this screw mounts to the bottom, it's 23 millimeters. So the 25 millimeter screws start looking really good. So let's do that. Let's remove those. I know we just put them there. Maybe let's just suppress them for now. Hey, that doesn't work. Okay. Let's quickly remove them again. But it's also like really close. Like I don't think, like we can't put a heated insert here. But what we can do is also like the bell, like this is where the belts come in on the side. Let's see. Hey, this is more complicated than I thought. This is more complicated than I thought. Like, we definitely need to modify this part quite a bit. We need to move the screw holes back for sure, because like they're too close to the front part. We definitely need to move them back. And those are definitely out of realm of possibility anyway, because like they're directly above the bearing. So we need to move those back and those also back. So I wonder whether it makes sense to use this part at all, or whether we should just like design our own part altogether. I mean, ideally, like from positions, we can now put in a screw here, basically. We can technically put in one here in the center and here. There's also enough room here to put it directly on top of the bearing, maybe. But then we need shorter screws, which we don't have available at the moment. So then we would need to have like a new set of screws. But this would be perfect for like 12mm screw. I expect this part to be much easier. Okay, then let's just ignore the part for now and just go back to what we had. We just decide on arbitrary mounting points for now, and then we just have to adjust the part to make it work. Let's actually just go back to this. Then let's just create 2 more mounting points. Sure to activate compound again. So let's just create 2 more mounting points here. Let's quickly take this and that circle. And then we can just set screw diameter, screw head diameter, and heat insert diameter. So let's quickly do the screw head. Well, let's start with the screw again. For the screw, let's use a shorter one here. Wait, let me just hide the bottom body quickly. That was the top. So let's do that. Then let's cut the screw head. Wait, screw head. Right. Here we go. And then we need on the bottom, we need a heated insert. Oh wait, that was wrong. So we say from object, let's clean it. From object, and then we say distance minus heat insert height. Perfect. So, oh, but we actually don't need to reserve space here for the head, because this will be in this like other part. We can actually remove this one. Okay. And then let's quickly mirror that across. And then it looks pretty ugly, but this will technically work, I think. So what we can now do is take the other component, if Fusion allows us to. Oh, we removed the joint accidentally. So let's take the center position here. And create a joint. Okay. Then we need to modify it. Let's see how it goes. So technically, the first thing to do, I would remove like, let's really just extend it to the sides, because there's a lot of space here for those two screws. So let's use those. So now wait, we need to break the link here, that we can modify this part in our design. Okay, so we remove this. We just need to remove the chamfers first. Otherwise it will be really horrible to work on, isolate. Let's see. So let's also just remove all the fillets, chamfers, at least the ones we can. Okay, that should be good enough. I mean, ideally we would have this one removed as well, but here we go. Okay, now it's like nice and boxy. And later I would just split the body in the middle, and then like whatever we do on one side, we just mirror over to the other. Then what we can also do is we can actually just go ahead and delete this entire hole here. Because we won't use that. And then actually like here, this one we can also delete. Okay. And then also let's remove this here. If we can. No, it doesn't allow us to do that. Okay, then let's just take it as is and extend it out. Looks a bit ugly, but we can improve in the future. So we just extend this out, and now we can make use of the same screw hole position. Let's actually quickly, before we do that, really try to get rid of this chamfer here. That would be really important. Just most likely need to find the one that we can delete first. Here we go. Yeah, okay, this unlocked everything. Okay, perfect. this one we can't delete again. Okay, I think with this we can live. So let's extend this. Just also have to keep in mind, right, we are printing this like on this surface here. So let's keep that in the back of our mind. Then if we use this, we don't need this extrude here. I need the sketch. This screw head extrude we don't need. And here we reference that, but we can quickly fix that. I'm just taking this one and that one. No. Should start naming my sketches again. But now we can basically just take this and we extend the screw hole through our part here. And it's actually like this like chamfered area, so let's just add like 10 whatever, just like to make sure this goes through. And then we also need to do the same for the screw head. The screw head goes here, and then the distance is the screw head height. And let's just make it symmetric, so we cut it in this like chamfered area as well. Okay, so now the important question: how long does our screw need to be? 24.6, which is perfect actually, because we want to use 25mm screw. So what I would do, just like that, it's like flush on the bottom. Instead of cutting the full screw head, let's just like move up like a little bit. So we just pull the screw out 1mm. Plus one. Hey, what's it? What's now? -1. Doesn't like that at all. Okay, for some reason it doesn't want that. Let's just do it this way. And now we should be perfect for like a 25mm screw. Yep, 25 something. Very nice. So then we still need to have like another mount. The question now would be, so we don't have like a lot of space in the middle. Actually, not quite sure if we need this wall here. I think we can get rid of this wall, so it causes more trouble than it's worth. So there's not a lot of opportunities for us to put screws. Like one option, we can't reserve this spot here in the middle. But then we would need to extend the part to reach there. I don't feel like 2 screws are enough. Like we should definitely have at least 3. Hi Dowder. Going quite well. Like I have a lot of technical issues today. I'm not sure if you can see that, but Fusion is very stuttery and not very cooperative. But we are trying to adapt the toolhead mount from the V0 to our like very ugly block here that holds the X bearings. And then basically as soon as we're done with that, I will throw it on the printer and then we can like start building some stuff while it's printing. So that's my master plan at the moment. But we need to find like a 3rd location for the screw and I don't know where to put it. Like this black part needs 1 more screw hole. I mean, we can really just extend it. The problem is there's also like this other part. Let's maybe also pull in the other part. Let's actually like delete this useless group. There's this other part, the strain relief. I'm really trying to like reuse those parts from the V0. Okay. This is the strain relief. So it's just bolted on top of each other. So this goes here. And with a very laggy animation, Fusion tells us where part goes. So this tells us a bit more how much space we have here. So technically, oh wait, let's reapply our changes here. We extended this already out, so we can have the screw hole here going through. I mean, technically, we can extend this middle plate to reach there. Is there a specific reason to use the V0 mount? Not really a specific reason, it's just laziness in a certain sense. Because having the V0 mount allows us to use the V0 tool heads. Like I'm going for the Bowden tool head. Just because like the motors we're using are super weak. Not quite sure what you saw so far, but like we're using these like super flimsy cheap stepper motors. So just try to have like a super light tool head. And at the same time, I think it's just a convenient thing because then we can like swap out the tool heads with whatever is available for the V0 system. So we can go with the full mini stealth burner with direct drive and stuff like that. So that's why I kind of like try to just use this like one part from the V0 just that we can like mount all different tool heads to it. Because then you also have like all different hot end mounts that come with that already. So we don't have to reinvent the wheel in a certain sense. So I just like try to have the mounting the same. Like technically we could also drop this part. The only thing we really need to copy, right, is like these 1, 2, and then here on the back, this hex. As long as we have that, we are golden. But then yeah, I figure we can just use this one part. We most likely will later have to work a little bit on the belt spacing because mine might be a tiny bit different. But yeah, that's why I like try to like reuse this one part. But I'm still like trying to figure out where to put like 1 or 2 more screws. But let's just do the following. I don't want to extend this middle part because it's quite weak. So let's hide that. Let's remove the chamfers. We can add all the chamfers later again. Oh, we have to. It also doesn't matter. We are only modeling one half, and later we just mirror everything over. I also didn't remove the hole here. So technically what we can now do, let's just create a sketch on that, maybe not on that side. Let's just create it here on top. Oh wait, we are not. Firstly, we don't have the component selected. But secondly, we should go all the way to the end because we already worked on that. And there's more chamfers now. Here we go. We deleted the chamfer after we did extrude. Okay, so let's just do the following. And let's just aim for this hole here. So let's also like project this, that. Let's really go like really for center, then we just do half what we need. I don't know, let's say 6 millimeters should be fine. And let's also set it vertical. And we need to connect this like that. Okay, let's just set this here to this like lower level. Oh, we need to do it like this. Here we go. Now the only problem is that I think the strain relief cuts a little bit into that. Like we don't have that space necessarily completely. Which is a bit of a shame. I understand, and it may look expensive even though very cheap parts it is. Yeah, exactly. Like actually like the parts you need for the Visor tool head are not super expensive. Like it's mainly like the little fans, right? It's the only thing that really kind of makes it more expensive is you have 2 part cooling fans, but it's like €2. And then you have like a very fancy looking tool head. And it's also, there's actually, I'm going to use this like Creality CR10 hot end. Like this entire hot end assembly you can get for like €4. So it's like dirt cheap. Comes with extra nozzles as well. And there's actually like already mount for that. We can actually like, let's quickly finish this up and then I'll throw it on a printer that we can print it. And then we can do like a quick test fit with the hot end in the tool head. Because yeah, it will look fancy. But yeah, it will be like a very, very cheap machine. Let's just quickly figure out how we do that. The main problem is like the layer lines go like this, like from left to right here. So this is relatively weak. So we need to be careful. I don't think this is really working. I think what's better, because we have this conflict there with the tool head. I think what's better is if we set this hole directly in the center. Like if we extend this, yes, back further out, but then put the hole not left and right, but just one in the center. And then I think we are golden. The only problem is in the center that we don't have lots of space. Because in the center, I showed it, like we have those like cavities here for the two linear bearings. So if we do it here, it's not really... Only bad options. I did not expect this to be so difficult. I also need to quickly check like which screws to use, because we don't want to use like tons of different screws, right? So this is again like 9.5 millimeters. So we would need to put, if we put a heatset insert on the bottom one, that gives us another 4 millimeters, so we are 13. So we can't use the 12 millimeter screw, or we put the heated insert on top part from the bottom, like the blue line, but like from the bottom. Then we need extra 3 millimeters on top, which just makes a collision with the strain relief quite likely. I'm kind of inclined to just use 2 screws and call it a day. I mean, we can also move the strain relief a little bit further back, right? That would also be an option. If we extend the entire part, the only problem that would cause, I mean, we have enough space, right? Because like the depth is there, just because like we are like V0 only has like very like narrow linear rail there, so the strain relief needs to be quite close, otherwise you're colliding with the back of the printer. But we have lots of space here because we use the 2 linear bearings, so we can just move the entire thing back. Let's do that. Maybe we can come up with a better solution later, but for now let's just take this and add like 14. Let's make it an even number, 15 millimeters. And then what we do here is we firstly quickly ensure we have the right part selected. So let's put a sketch here on top. And we have this hole here already, so let's just reference that. The build volume will be like 120 by 120 by 120. But technically you can scale it, right? Like this is like, I didn't cut the rods to length yet. All you need to make it bigger is to have longer rods. That's really all that. That's really all you need to do is like have longer rods and you can scale it up. But yeah, it will be tiny. That's like small, cheap. So, wait, screws. Oh yeah, we have the heated insert here already. Let's quickly check. So from the middle to top we said it's 9.5, so 3 millimeters. So we need just one circle here, which is the screw head's diameter. And now what we do is firstly, let's extrude this all the way. And then we need to have this screw hole here, right? This head. So we take this and that. And now we just set an offset. Or no, we say from object. And the object we have will be this. The bottom from where we mounted. And then the distance, the offset is 12. Nope, minus 12. That's our screw length. Just if we have a little bit of like space, we say 13. And then the distance is to object top. So basically this is now exactly deep enough that our screw reaches this heated insert down here. And that should be fine. I just see like there's one problem. There's this hole here. We extended, of course, all the way to the back, which we don't need. So we actually need to plug that before we do the cuts. I'm getting Rook vibes from this. Yeah, it's definitely like you're getting the right vibes. Like lots of printed parts. Basically, not a lot bought. Like the only thing that's really bought is like the rods, of course. But from the structure, beside the rods, everything else is printed. Like also the motion system, like will be all printed basically. Like all the roller bearings and stuff like that are printed. Give me like another 5-10 minutes to finish this up, and then we put together like the final version of this thing, like with the roller bearings installed, and you will see it's like all printed. Yeah, the extruder we will need to figure out ourselves. I have some standard parts. Oh, I actually didn't show them. Like I have those like normal like extruder gear thingies. But because we use this like very specific motor, we need to design our own extruder. So that will be fun thing to do. But yeah, for now, my main goal is to have the motion system working. So let's quickly check what they did here. So we need to extend this. Both of them we need to extend by 50 millimeters, right? That's the same. Let me select this face here. Can I? It would be interesting to see a design that doesn't use 3D printed parts. What do you mean by doesn't use 3D printed parts? Like only purchase parts? I'm not quite sure why it doesn't let me here select it. Something sketchy is going on here. I want to have this surface. But it's not what I want. Okay, leggy fusion is not easy, and if it doesn't do what you want, it's even harder. Okay, for the life of me, I can't figure out why it doesn't want me to do that. So let's do this one first. And now I just need to have this like... Okay, let's make a sketch. I give up. Nope. We go up here. So we select this one, this one, this one, 15. This one, 15. Oh, that's how I want it. Object. Okay, wait. I'm struggling really hard with that right now for some reason. Let's do the following. Object, we take this, and then oh, we just missed to extrude that in the initial thing. Now I understand. Okay. Oh, it's a fillet. It's a fillet we forgot. Chamfer. My bad. Here, now let's remove that. Here we go. Okay, now before we make those cuts, we need to take this and also pull it 15 out. Then we have like the original depth, basically just like further in front. And now let's hope that this is enough. To clear. Oh yeah, barely, but a bit. Isn't stepper motor non-polar? That means you need to use a custom driver. No, we modified it. We modified last stream, so now it's a bipolar driver. Like by default they're unipolar. That's correct. They're unipolar and 5 volts. And you see like the little red cable thingy here. So basically what we did is we cut the traces here on the PCB in the middle, and we removed the red cable. And now basically the two like halves of the stepper are separated. So now it's a bipolar driver. That allows us to run 12 volt instead of 5. That's the one thing, and we get double the torque basically. So that's the modification we did last time. And I also did like a proof of concept that we can run it with a normal printer mainboard. Most of these DIY builds assume that you already have a printer. Nothing wrong with that though. Yeah, like, I mean, that's the thing, right? Like, you need a printer to print a printer in a certain sense. I think only using off-the-shelf parts would be quite difficult. I think then you're just better off like buying like a used printer in a certain sense, like just like a used Endo 3 or something. I can get motors for like $1 from a flea market. Yeah, I'm trying to have everything like easily accessible. It's just like a normal like shopping list basically. The only thing that I think we talked about in the beginning, right? Like the mainboard is the only part I assume you can find used. Because yeah, if you buy one new, it's like half the price of the entire printer. I built my printer using those scrapper motors. Yeah, I think like stepper, right? They also didn't change like a lot in the last 50 years. It's really simple. Modified. Yeah, I mean, it's really simple, right? You just cut the one trace and then like it's modified. You're kind of over that time. The original RepRap had printers that did not need printed parts. Yeah, that's true. Like all the way in the beginning, but then like they used a lot of like wood cutting, right? And things like that. Acrylic laser cut. Like it wasn't RepRap, but like the A8 printers, right? They had like this like laser cut acrylic parts on the side. So I mean, like you can build it without printed parts, but you still will need to like build things in a certain way. Okay, so that would mean we are now good for having that mounted, right? Because we have the 4 holes here. This is accessible in the back, so that's also good. Let's sort of following, let's quickly add the strain relief back in. And then let's add the hardware. And then maybe before we add the hardware, let's just add some chamfers and stuff like that, just make it pretty again. And then I think we're good. Now we can like send it off. For printing, this took longer than I expected. Yeah, let's quickly double check, just so we have quick sanity check. So this goes from top to bottom. This is 25, that's fine. Then, oh, I think I see a problem. So this screw goes from here to there. That's 13. That's perfect for like a 12mm screw. And now here comes the problem. This one goes from here to the bottom, and this is like super bad. It's like 22, so that doesn't really work. And on top, like the screw head will stick out here where you have to mount that part. So let's modify this one here to be a bit different. Because technically what we can do is we can use a 12mm screw here. Right, from here to there it's like 9 we said, right? So we cut the head into the top, then 6mm, and then we have 6 plus 4 is 10, yeah. Let's do this. Okay, we are almost there. But we can already make this part pretty. So let's just add some chamfers and fillets. And we still have the original on the other side, so we can like peek a bit what they did. Okay, I think that's all we need for fillets. And let's just add all the chamfers back we deleted. Oh, there's a problem. Okay, if this doesn't want to be, then it's fine for now. Let's not worry about that. Yeah, it's impossible sometimes to control this. I'm not sure what it is. Okay, let's add chamfers here again. And no, it's also 0.5. Let's add one here and here. Let's see if it freaks out. It does. Yeah, okay, so the only problem then we have is this section here that doesn't want to be part of our chamfer. What we can try is to delete this one here. And then we can try to add this. Yeah, this quite similar to the original one. Yeah, let's do it like this. Okay, and now basically my idea is to just split the body in the middle. Am I not showing anything the entire time? I'm so sorry. Switch scenes, please. Yeah, sorry. My bad. On the Red forum, there's a post of a boy from Pakistan that DIY'd his own printer from scratch because he said printers are banned on Pakistan like 6 years ago. I wonder what happened with that project. It's really cool projects actually, but yeah, he didn't update it in the end. Okay, mid-plane. So let's just attempt to rotate the model and get a center from those two. Let's also move this over here so you can see something. Okay, then we split this body because you see like one side is modified and the other side is like the stock plus like weird stuff. So we just split this body in the middle here. Okay. And the support here in front is like little thingy. Like if you ever build a V0, like there's this like little support piece in front, we can leave that. And now this part we just remove. We don't need that. And now we just mirror this body on the mirror plane. And let's see what happens if we say join. Ah, worked. Okay, perfect. Oh, actually, we don't need this plane. Let's not create a new plane. Yeah, let's create one. That's mid X. That's mount spec. Perfect. Okay. Then the black part technically is done. So technically we could already send it for printing, but I want to quickly wait, just in case something changes. So we still have to fix up this one here on the back. So this comes from this mirror here. From this one here, right? Yeah, exactly. We just mirrored that to the back. That's a shame. So we can't do that. Let's just model it on top, basically. Let's just go here before we add this. Let's just model this on top in a certain sense. So we project this hole. That's not what I wanted. Then we need a screw head diameter. Oh, it's a screw. No, screw we don't need. Screw head diameter. And we need the heated insert. Okay, let's start with the following. So we cut the screw head height. So we can have like countersunk screw head here. And then the second thing we do. Oh, why is the sketch not defined? That was a random circle. And then we take this, which is the heated insert, And we put this in here. And then we say distance is minus heat insert height. So actually, before we do that, let's fill up the hole we made before. And then let's make a new hole from the top. Like, it's not the most efficient way to do that, of course, but... So we select those two. He hasn't updated in years. Oh, well, that's a shame. I hope nothing bad happened there. But it's like quite powerful. Like if you have a 3D printer, like you can create so many things. But it's also like, how do you prevent people from building printers? Because like you can build printers from like anything, right? I mean, I'm kind of like showing that, right? Like it's just like stupid simple steppers, and yes, I have a printer to print a printer, but like as we just discussed, right? Like you don't need necessarily a printer. You can use other means of making things. What's it doing now? Oh, I set the offset. Distance. Heated insert height. Here we go. Okay, and then the only last thing I would do, let's just plug the hole from the bottom. So we take this and then we say object. And then the offset is 13. Let's just take the screw length we use. And then to object bottom, and it just like plugs out the hole on the bottom. Cool. Then we need to mirror that off to the other side. 1, 2, 3, 4. Oh, features. 1, 2, 3, 4. And the mirror plane is mid. Let's move it here. Okay. Then this would be our part. Let's just add some chamfers and make it a little bit less boxy. And then I think we can send it to print. Chamfer. Oh, also before we do that, let's just use push-pull. Oh, we also wanted to remove the center wall here. So I just pushed it down a bit that we have like a little bit of spacing there. We also wanted to remove the center wall. Yeah, we have to do it in the very first sketch we ever did. So we have to just connect it here. Let's just do it again here. Be careful with the bearing carriage. You can't put that much pressure on plastic bearings because they bend. The screws could squish them. Yeah, well, you definitely can over tighten that. That is for certain. You can definitely over tighten that, but we already have it here and it works well so far. Not saying that's perfect, but oh, we broke something. See if I can rotate that. Relink. Oh. Wait. What did I do now? We cut out this middle side. We extend that. Oh, I think this is broken now. Yes, because it's open, we have to patch this hole here. Yes, now it's working. Okay. It's quite a massive part. I hoped it would be smaller, but I don't see how we can really like remove a lot of material. So let's just... We go for quite a boxy look in general. Let's just make larger chamfers here. On front, let's keep it straight because we have this part. And let's take 1 millimeter. That's here. Oh. So I wonder whether we should like... Yeah, let's just do it on front as well. But let's do the 1 millimeter here. And then also here around the openings. So. This is how the finished package would look like. The only thing we now didn't do yet is we kind of need to have end stops here as well. The question is just, do we have the end stops on the tool head or do we have them on the thing? I missed one. Hi there, Wes. Where did I miss one? Oh, yeah, I see it right there. Thank you. Let me see if my Fusion wants me to add that. They also have another one on the other side? No. Here's complete. So yeah, so we didn't have the end stop yet, but I kind of also want to print the part quickly, just to see if it works in general. But basically my idea would be, and it really comes down to screws again, to have like 2 end stop switches here on the bottom, one to the side for X and one to the back for Y. But it's also like a bit of a bummer. Because technically like you can print the part on the surface, but if you now add like... I mean, holes you can add, but anything else will be a bit difficult. So I'm trying to use... I've been lurking while tuning printer profiles. That's usually what I also do while watching streams, tuning my printer. Yeah, so basically I want to use these boards, which is like the end stops. I actually didn't check. Is that like, yeah, we can use the screws we have. Now here's the interesting question. If we would I'm thinking whether we can like repurpose the screw here on the back. Whether we can like flip it around, that's like from the bottom, and then put the board from the bottom against it. But I kind of want to have only one screw then, right? So we need to find something else to like secure the board like in X. Like in one other dimension at least, that like it doesn't rotate around the single screw. I think like one screw is fine as long as we like fix it in place some other way. Let's just think, like if I put this here, we can, yeah, screw would be on the back, that's fine. For X it works, for Y it's a bit difficult. For Y it's a bit difficult. Let me quickly preheat the printer. Let's do that. Then we at least do that. And the other one, let's also preheat that. Yeah, I think I would skip over the end stops for now. Just because I really want to get printing, because like this will print a second. Let's create components from that, because we can only export components. So this is the we need to give this like a name. Let's just say X carriage A. This can just print like so basically I have this like export script. I just give it a name with like E on the beginning, that will be export, and then like just a name, and then on the end it's like the rotation, in which rotation it will be export. So this is just export as is, and let's call this EX carriage B, and this one we need to flip 180, and then this one is X carriage C, and this one we need to flip 90 around X, I think. So then let me quickly export that. Should give us a small confirmation. And then we can see in Orca. And quickly pull them in. Oh. That's on the wrong plate. So I think the V0 will have to print 2 parts, and the switch wire can print 1 part. Let's just quickly slice this plate. How long? 30 minutes. So this will take 30 minutes. And how long will take one of the other ones? Inside one more plate. 30 minutes. And this one will take 20 minutes. So we need 50 minutes to print that. Maybe add like a 3D printed pin. Yeah, the thing is like, let's just fire off the black part because the black part won't change. Let's fire off the black part on the printer. Then we get going. Wait, but we need to make this part needs to be printed in ABS because we have ABS loaded. I tried printing PLA with or ABS with PLA temperatures this week, and it didn't turn out well. Like it turned out well enough that it took me quite some time to figure out what was wrong. Like it just wouldn't stick. Like it did like a couple of layers and then like it just came loose. It didn't warp. It just came loose. Man, that took me a while. Okay, we will have fun now with printing. Wait, if I go to Fusion, yeah, you see the browser, but I need to switch to the right tab. And then let's just do this. And then we have it on the side. So we now have basically 20 minutes to figure out what we do with our end stops. Time is ticking. So let's maybe also, I didn't do that yet. Firstly, let's save. I do not trust Fusion at all today. Like this is so sluggish and weird. May I search? Oh, it's in recent data because I haven't opened. Like I have a Ender 3 assembly flying around here. Ender 3 assembly. Because the end stop thingy we use is an Ender 3 part. Like they're so cheap. Like whatever comes from Creality, Ender 3, CR10, like all those like OG things, you get it for dirt cheap. Dirt cheap. Yeah, I see it already. If Fusion doesn't do the rotating thingy, like this is exactly the part we want to use. So let's just say save copy as, so we just like export the component out of there. And then we save it in my my working title for this is the Moron 0. Because it's just stupid to build like a printer with just like motors. So Ender limit switch. Then just goes in imports. Okay. And now what we can do is we can just import and it doesn't even scroll properly. Sorry, Jonas, I totally ignored you. I see you also use Orca Slicer. Do you happen to know if you can somehow share profiles? They say I would like to sync them between Windows and a Mac machine. I don't know. What I did before in Cura, and that worked semi-okay, is when you use like something like Google Drive, right? You can add random folders to be synced. Oh no, not folders. But what you can do, Not sure how much you're into computers and stuff. So I might now explain something very stupid or something completely new to you. There's something called symlinks. And a symlink is basically like a link on, how do they call it on Windows? Like it's, you know, like when you have a file and you create like a link to that file somewhere else. I don't know the English word for that, how it's called in Windows. In Mac, it's called the alias. Okay, you're deaf, amazing. So basically you just put a symlink into your Google Drive or something. And like you look where Orca stores the profiles, and then you make a symlink to that location and move the real files into Google Drive or like Dropbox or whatever you use. And Dropbox will sync the files, and Orca will directly use the files from Google Drive without knowing, because it's just a symlink. And you do that on Windows and you do it on Mac, so basically both write to the same folder. The caveat comes, I don't know if Orca on Windows and Mac use compatible files. On Cura that worked because it was written in Python. I think Orca is also Python, so it was fine. But might be some crazy stuff that like they use different formats or \r/n and stuff like that. Oh, would have helped if we actually loaded filament, right? Let me quickly, maybe while I do this, let's just quickly purge that out. There's some white stuff. We don't want white. Okay, that should be fine. Ah. One second. Oh, and second attempt. We'll try it. I was thinking to use rsync. Also works, like, but then you need to have it in the same network, or you need like public OSAMs or whatever. So yeah, that's why I use Google Drive. But what you should do, like if you use Google Drive, use rsync to make regular updates of your stuff. Because chances are at some point like something breaks. Need to check where to save the profiles. Yeah, but I'm pretty sure you find it on GitHub or something, like somewhere. Somebody most likely has that. Let's see, now I have to fix the webcam again. And also totally rely on you to check the print for me, because I usually like do stuff and like the print does horrible things. And my headset died. But here's a fun thing. Here's a fun thing, Jonas. Like, if you use Orca Slicer, I had like an absolute like what the fuck moment yesterday. So in printer config, like in this like window here where you have the motion ability, you have, I actually didn't save it, like you have those maximum accelerations here, right? This overrides your clipper config. Whatever you put here, Orca will apply in the G code, and there's no way to prevent Orca from applying that in G code if you use Clipper, because it's like emit to G code checkbox here has no effect on Clipper. So my filament sensor is a bit wonky. You see here the acceleration, like it's set to 10,000. Like whatever you have in Orca, it will apply to the machine. Like it just writes that in the beginning of the print. And I didn't know it at all. And I had like 1,000 millimeters per second squared here. for the entire time. I was like wondering why no matter what I did to my clipper config, the machine didn't go faster. See, I'm a little bit concerned. Yeah, I think something is missing from that. Right. What is it doing? I feel like there's a part missing. But Orca doesn't allow me to look. Today, like everything just is like weird for me. Like what is this view? What is this supposed to tell me? Ah, here. Oh no, it is like this. Like this little like teeny tiny fizzle here in the middle is definitely not there. It kind of is. Okay, let's roll with it. Let's roll with it. Let's see. Then we go to Fusion again. Okay, so let's find a nice spot for our limit switch. So we need to have at least one on here. So my idea was to have it somewhere here on the corner. Something like this, that we mount it there. The only problem then is really like we don't have like a lot of depth to screw into. Like, I mean, technically, like here's the thing, like we only need to home X on here, right? Y technically can be done with the end of the gantry. So if we do something like this, let's just maybe move that like 0.5 millimeter back, let's say 1 millimeter. If we do something like this, but like I'm not quite sure about the position yet, right? Because we will have the tool head here, and then like this will also influence how far out that switch needs to be. But that was kind of my idea, to kind of have it here. I think my Triton could be much faster, but I'm just scared to up the acceleration and speeds. It's pretty reliable at the moment. Yeah, it's also like a thing, like reliability definitely has its perks. Like for me, like this is amazing because now we can prototype relatively quickly. That's why I like really crank this one up, and also the switch wire. But yeah, normally like Nero had this discussion today on his stream. Like I was just watching Nero, or what's his new name, like Canop Maker, and he had discussion whether the i3, like the Prusa Mark III, still a good printer. And his point was yes, because speed doesn't matter if it's reliable. And I kind of agree. Like if I have a printer that I can just send something to and it just does its thing and I know it works, it's amazing. Like that's like worth more than like a fast printer. Which Triton size do you have, by the way? I'm kind of low-key looking, maybe, at some point into getting like a 300 or 350. $250, yeah. It's also like nice because it's then fast to heat and everything. But like I feel like I have the switch wire for like the mid size, and I really like to have something really big where I can like print bigger parts, and I'm totally missing that at the moment. Yeah, I think this is the only position we can put this in. Oh, you know what we can do? Let's just go all the way in. And also put our tool head. So yeah, we have to completely assemble that. So we can say that this here, if we hide the support there on the front, this goes here. Oh, we lost some parts there. So before we do that, we need to tell rigid group, tell Fusion that these parts are all part of one. Oh, okay, we have to do it in another file, I guess. I think if I get a second properly, will be a 0. Yeah, like a 0 is amazing for exactly that. Like if you just have something you quickly want to print, it's amazing. Like it just does a thing. Like it doesn't need like a lot of like time to warm up or something. Wait, let's do capture design history and then let's do rigid group. So we just like bolt everything together. That's like one part, and we can like save that. Can go here and it will like complain that it's out of date. Okay. And then we can now do our joint. So center of this thing goes here. I still lost all the parts. Okay, let's see. Can we do this here? Yeah, now it's one part. Okay. Then we do a joint. Let's try this again. So this goes here in the middle. Ah. Include child components. Now we have it. Okay. Step by step. So this. That's all I want. I don't want to transfer. Okay, last attempt. Yeah, but it always selects that stupid. Okay. Why doesn't it do that? It's one part. Let's just try to save it again. I never use the templates. Yeah, I'm also like a beginner. That's the main problem at the moment, I think. So I'm just not sure. Like technically, this is like all one shebang. Like it's like I bolted it together with the rigid group, but for some reason it doesn't want to. I mean, we can also try. Yeah, exactly. Like this exists already. Let's try again. So if I now say this, yeah, now I only have the body. Wait, if I select this explicitly, okay, screw that. I figure this out later. Let's just move. Because I just want to have like a rough impression where this needs to go. So how much more width do we need? Because like if we look at this switch here, we already see like it's not far enough out, right? Because like we want to home on the edge. The other thing is like looking at this part here, right? The switch, how we currently position it is like behind, like these are the two bearings we are modeling around, like the switch is behind, so there's not anything here on the side to hit. So that position of the switch doesn't work out anyways. You should be able to make that insert and the hole and then after that mate surfaces, but I think there may be orientation constraints that overlays. No, like the thing is like it creates the joint between this like insert or the body, but not the entire part. But I try to like tell it like this is all one thing. Like don't treat it like separately. But for some reason it doesn't want to do that. But nevertheless, like the positioning of this switch doesn't work in this way. So, oh. So we kind of need to have this like more in the middle anyways. Like anything like where the lever is not exceeding the position of that rod by lot is fine. So technically something like this could work. But then I'm also thinking whether we just not move it to the front. I mean, from the position here, we have a bit of leeway, but the problem is like we don't have a lot of like space to like screw into the material, right? Because like there's like the rods right away or like the bearings. Okay, let's also send the top part already to print. How did the V0.1 do the end stop switches? Because the 0.1 also had like, because we're kind of like using like some 0.1 parts here. Print head. Oh, can't click that. Okay, 104. There must be an end stop switch somewhere, right? Oh yeah, here it is. There it is. So they put it on top. But then like there's a feature on the other side to like meet it. We don't have that at the moment. So they basically have it here on top. I mean, we could sacrifice one of those holes here, right? Like one of those screw connection. We have 1, 2, 3. Should still be fine. So technically we can do and we just like interfere with this one here. Now that would be like a bit painful, and you always have to unplug it when you take off the tool head to reach, because you need to reach this screw to remove the tool head. So that's not really like nice. Wait, yeah, there's not really like any good spot to put it. And the problem is we don't have like the 8mm screws here. Like I really try to like limit the screws, because if we would have the 8mm screws, we could just put it here in the middle, put a heatsink insert there, or 6mm, and call it a day. That's also like the question, like if we print that, what about mounting it more like in a trident? How is it mounted in a trident? On the X, not the tool head. Yeah, I mean, technically you could do that. But the wire harness on the trident is different, right? On the trident, you have the cable chains going from the tool head to the side of the Y, or to the Y-axis, and then over the Y-axis, right? And we just have the umbilical cable basically going out of the tool head on top. So if you would put it on the side, if we would put it to the side, which we would have definitely space to do, right? Like we can put it somewhere here. But then you have like another cable from a moving part that you can somehow have to route to the electronics. That's why I really want to have it on the tool head itself. Because now basically all the like cables come from one spot. The question is, can we not also use the same screw to just mount it? Like if we would align, let's say that. Yeah, it's too far out. Like if we have it here, but this is way too far out, I think. Okay. Yeah, then you want tool, I think. Yeah, exactly. Like if it wouldn't be for a cable, I think, I mean, I would consider what I saw. Where did I see that? Some printer. Like we definitely don't have to do both, right? What we can always do is we home X first. Like X is always home first, and then like the Y home switch is on the end of the, like on the back of the printer basically, but not part of the tool head. But then basically home X, you know that you're on the position for the. So you basically home X, right? And then you home Y, and you know you hit that because you're on X min or X max, and then you hit that. So you only have to have this one here, so you move to the side, and then the second one you move back. Yeah, exactly. One stationary, one on the tool head. Like, it halves the problem. I don't know, like, if I'm just making it difficult right now, or if there's really like not a lot of space to put that. Let's just put it on the bottom. I'm also like kind of having like a bit of like how's it called, like not really like able to make decisions right now. So we have here, wait, no, here we mirror this over. So how about we just don't mirror that over? Or at least not the... So we mirror the heated insert over. And then we have from here to here, 10 millimeters. So we could just mount it there. The main problem then would be that we have to print this one upside down. So let's quickly check Orca if we can do that. Or use sensors homing, but if I don't think the batch steppers, batch drivers have that function, yeah, that's a problem. Like, I would go for sensors homing, but because I kind of want to go for the Ender board because they're so cheap, they have the A988 stepper driver or something, and they don't have sensorless homing. But this is also like the older version of the board. Like, the newer versions actually do have the 2209 stepper drivers, which have sensorless homing capabilities. But let's quickly check. So this is the part we're working on at the moment. So what happens if we just flip that over? So if we print it upside down, quote unquote. Because if we can print it in this orientation, we can add some extra features to the surface to mount the switch. I mean, you have this rounding here that's not perfect, but should technically work. And the rest is fine. So it's mainly the rounding here that might not look super pretty because you have quite steep overhangs on the top, right? Like, I'm always like scared of printing round corners like this. Like, it will work. There will be usable part, and we have enough clearance there that it works. Might not look super pretty. Well, I think it's the best option we have. Not sure I would put any more responsibility in the steppers. No, like in steppers, I don't trust them. Okay, then let's go with that. So we have then 4 millimeters. Then it's just a question. That would mean we need to also modify this part a bit to have like a mating surface. But it should be fine. Like, actually, I have a good idea. I have a good idea. We have this like little. Oh, wrong. Yeah, we have this little like bar here, right? So these are the two bearings we are working on, and we have this little bar here. What I'm thinking about is like, on one side, swapping this bar for like a longer version, because like here we have space, there's nothing. The belts are here. Like, here we can extend it to the back as far as we want, and we can also move it, make it thicker or thinner to like adjust how far we need to move in. And this would be exactly like the tool head would be more on front, so we can really work here and adjust the Z, not Z, the spacing we need. So let's print this A upside down. let's print it upside down. But then I also would move this hole like further in. Okay, let's delete this entire mirror here. So we kind of have to plug that hole. I will clean up this file later. Because in retrospect, like we made the hole right in the beginning. And then we mirrored it over. And then we mirrored the body. I mean, maybe we can... Yeah, if I do that now, it will destroy everything. Okay, I'll do that. I'll do it tomorrow. I will rebuild this and make this a bit nicer. Wait, I kind of lost orientation here. So we want to remove this one here. Okay. Let's just make a new sketch for that. Yeah. Then we need oh wait, we're also behind the chamfer. Like, let's not work after we put on the chamfers. That's asking for trouble. Where do we do the other hole? Yeah, let's just go here where we do the other hole. Yeah, let's just quickly reuse the sketch here. So we kind of mirror just those two circles over because that's exactly what we need as well. Okay, so we want to use a 12 screw. I think for the board we need to factor in like 1 millimeter, so we have like 8 millimeters left to screw stuff. So the no, we have like 11 millimeters. So technically we can also put the heated insert on the opposite side, then we hold still the parts together. So that means we take this here and we just plug that hole. Oh wait, we already have the heated insert here, right? Oh no, wait, it's just a screw hole. So we plug that. Nope. And then we take the heated insert diameter. And we're here and say minus heated insert height. Oh, without the minus. We cut into that. And then on the bottom, we take the heated insert diameter and plug the hole again. It's always easier in the end, like when you know like stuff like that needs to be special. Let's see. Oh wait. Shouldn't have selected the center. Okay. Now we have this here. Oh, we also wanted to, yeah, let's plug this hole completely off. Because I kind of want to move it a little bit inward. Wait, no clue what it's doing now. So let's just take all three, not the other one actually. Then we hide top one. We need to do it in 2 steps because we already split the body. Oh wait, we don't cut. We join. And then we take the same 2 from object. Oh, but now that I see that, right? We also can't move it in a lot because we don't have a lot of space here. So we might have to live with that standing out a bit. And a ballistic tag. Glad they move it all. Yeah, definitely Jonas. They're glad that they're moving. It was like quite a struggle last stream. Okay, so I'm still on the fence. So we can't really move it in further because if we move it in, there's not enough space. Let's quickly go back where we inserted that thing. So if we just moved it to where we kind of would put it here. It just stands out like quite a lot. I mean, technically it would be fine. I'm pretty sure it's still kind of in range with what we need anyways, because the tool head is quite wide there. The tool head is quite wide there. Alright, let's roll with it. I'll just move that forward in the timeline to where we're working at the moment. Let's see. Okay, we can also. I should have started the top part now already. Let's give this like 1 second to cool down. So. Okay, so this is the corner we want. Yeah, let's just see how it works out. So we plug the hole on top. Yep. That's the opposite of what we want to do. On the bottom, we also need to seal it up. Man, this is ugly. Okay, then we cut heat inserts. Oh. I keep adding that as an offset. Heat insert height. I'm struggling. Oh, by the way, I just realized you don't see what I'm doing here at all. Huh, sorry. I need to move the tool windows over. Header click. When are you editing? When are you editing on the far right? I can't really see anything. Yeah, that's exactly what I just realized. I'm really sorry. And then we also just need to punch the hole from the bottom. Ugh. I really have to go through and like clean this all up. So we take it from here, and then let's just say distance is 13. This might just be too short. Because like the screws we use are 12 millimeters. I mean, we will bring this one a bit closer. And we could use another 25 here. Let's actually do that. Yeah. I'm constantly redoing this. I'm really, really sorry. So we take this. Patch this hole. Then we basically just create a heated insert here. Heated insert height. And then we just take this and punch it through. Okay, and we can see that we have, yeah, we have some random geometry here. I'll definitely make this nicer tomorrow. Okay. So basically now we can do the following. We just create a joint between this and that. And yeah, there's some solder connections, so we definitely need some space. So let's just move that down. Let's just say 3 millimeters. Let me quickly see if we moved it down 3 millimeters from the top to where we screw, it's 24. So the screw will stand out like 1 millimeter. So we actually need to move it down one more millimeter. Okay, it's good that we didn't start the top part yet. But then, weird question. Hey. We didn't really consider the screw here on the back at all, right? This is just like some random hole now, because there's no screw head or heat insert whatsoever. Because this is a heated insert. Yes. But then we don't have any screw that can go there. So it's also something we need to patch up. How about... I really struggle with this stupid like end stop switch. How about we put the end stop switch on a separate like printed part? Like we have the two mounting holes here that I kind of like butcher since forever. I mean, we can also extend it here, right? So the height is 19 millimeters. Oh God. Wait, let's check our printed part. Let's do something fun for a second. So, yeah, like the middle part here is a bit butchered, but overall it looks quite okay. And it's definitely strong, which is nice. There's like this little support piece, which should break off. Here we go. And then this is how it mounts together. So, yay, we adopted the V0 part successfully. The only thing we kind of like almost screwed up, but luckily didn't, is like there's just enough space here to route the cables up, right? There's like this cable tie point. Now we have like our enlarged mounting pattern. So that's fine. So that's a success. Yay. I'm still not sure what to do with the end stop switch. So there's just really not a lot of space. I don't want to make the part bigger just because of the end stop switch. Okay, let's make a super simple thing for now. So we just make a little like throne podest here, whatever. So this, let's just quickly put this here. Let's just say this is like, I don't know, 1.2 millimeters. That's far enough. Oh, wrong cam. See, I did that before. I'm really sorry. So we just do this. And then basically here we just say tolerance. So we make this little like nubble in here. So one is fixed by a screw and the other one so let's just make sure that all those are construction lines. And then we can just extrude this section here. Oh, there's something missing. Let's quickly add lines here. And then we just say distance to object, bottom of this board. Okay. And then the second we do, from that sketch. Oh, we have to sketch in the wrong thing. Aye. One second, let's quickly move that down here to the mount. Like sometimes Fusion is really annoying. Like now it has this like body 2 selected here and I can't deselect it from the tree. And there's no way for me now to move the sketch because it always has the body selected with it. Okay, let me quickly reopen the file. Hi there, Eric. Do you have to use that PCB? Could you just use the switch and embed it into the part? Yeah, it's the thing, like, I kind of wanted to use the PCBs because they have like the little thing, but it's also like the part, like it looks like there's a lot of space, but there's really not because of the bearings in the middle. There's not tons of space. Next challenge, make a 3D printer with less than 100 euro CAD. No. I'm using the free version because I'm not using it commercially, so it's less than 100. But yeah, I fell into the trap. That's the thing. Like once you like learn like a tool, like for now, or by now, Fusion is just like the thing I know how to use. Oh, come on. Sometimes I hate it very much. Let's do a sketch again. Yeah, but it's a tool I know how to use, so. Maybe I shouldn't say know how to use. The tool I know the most how to use. I'm not gonna claim I'm an expert or something. Let's quickly remodel it. I'll see also why we had this. Okay, so we said 1.2. Oh, Canadian dollars. Well, sorry, I meant to. I thought you meant the CAD program. Yeah, like not quite sure like how the Canadian dollar is valued. To be honest, that's outside of my daily. I know the dollar and euro is like $1.1 is €1 or something like that. That I know. But I think the Canadian is less than US, but then yeah, that's all I know. Okay, let's try this again. So we extrude this section, including the circle, to object. Okay, and then the second one is we take this like little section here, and from object here, let's just say like 1, 2, 2.5. something like this. So we just created like a little nubble here that we print, and we will chamfer that in a second. And this should now mount our board. So basically from the top of the PCB to the end of our heat insert, it's 25. So we can use our screws. And now the question is, do we just I'm kind of inclined to just have the heated insert on both sides on top. That's like even. Okay. I'm messing up even more, but let's just take this. Pull it all the way over here. This is like the most inefficient way to make anything. Thread insert height. So we just cut the thread insert in here. Then we take the screw. The screw goes all the way through. Let's quickly check that we don't have any thread inserts in here. No. That looks all good. And now we kind of have to raise it up like another 2 millimeters here. Because the board adds another like 2, I think. It was bad selection. Yeah, 2 millimeters of height. So we kind of have to add that because now here it's only 23 height, but the screw will be 25. So let's add another sketch. And let's just create like a random rectangle. Put a point, like a diagonal through it. Put a point. Hey, I want to just put a point, not a line. Point. And this point is now on the center of the diagonal and on the center Oh, wait, that's not how it works. Center of the circle. Okay. And then we can just take this and say distance to object, top of the PCB. For some reason, I have to move the view for the OK button to become active. 68 euros. Oh, no. Like the 100 is already like quite a struggle. Let's quickly start the print and I can show you like my bomb. Like what I have at the moment. Okay, we need to add some chamfers, like we destroyed a couple, we added some. You win some, you lose some, right? Let's hide that board for now. Let's maybe add like a bigger one here. Right, I have this again hidden. Something like this, right? Let's quickly check if we have heated inserts here. So this looks all good. Let's quickly check if everything is still fine if we advance. I mean, ignore this random as tool head that for some reason we can't assemble. But I think then it looks quite good, right? Let's do one very, very quick section analysis on both axes, just to be sure that we don't screw it up royally with something. This looks good. This looks good. Heated insert, heated insert, heated ins. Oh, we have two heated inserts here. Let's fix that quickly. Oh, and then we forgot one feature. Could I send you a quick drawing of what my thought was somewhere? Yeah, you can on Discord, technically. I'm not sure if I want to post my Discord link though. My Discord thing. Will all the files be free? Yeah, of course. I publish everything. My goal is to have it like that someone else can build it. Kublik, I'm not quite sure. What you can do, just send me your Discord. Yeah. Yeah, Jonas, I remember you mentioned last time that you want to make a plotter out of it. And I actually keep that in mind, that it's like, I try to keep it like scalable with the rods, that you can make it bigger for a plotter. Kublik, just drop it to me to this email address. That's my support address. Like, that's public anyway, so. Or you send me your Discord. Both works. I'm just a bit iffy with my Discord. Wait. I sent you a friend request. Yeah, I think it worked. Cool. So. Okay, in the meantime, let me clean up that double thing. Let's maybe do it from the side. You know what? Let me just do it like this. Somewhere in this extremely messy yeah, it's such a funny bug. Like, you have to rotate the view to enable the OK button. So from here, I really have to clean this up tomorrow. Most likely just design it completely new. It's always good, like, if you have, like, if you know what the goal is, like, it's easier to design something. Okay. Let me see. I received the message. Yeah, exactly. Like, wait, let me. let me just quickly show the people what you sent me. And I think that's also like what I had in mind when you said that. My problem is that we would need to make the entire thing thicker anyways, right? Because if you see from your drawing, like the switch, how tall is the switch? The switch is 4 millimeters, something like that. Let me see. Maybe it fits. Hey. Go away. Where's my other body? Here's my body. I mean, you could embed it here, right? Like here, we definitely have enough space. I know, like from the bottom of this thing to here, it's like 6. So here it would fit. But then the problem is you need mounting hardware for the switch, right? So basically, you would need the switch, but you would also need the screws to... My main point wouldn't be that the thickness would be fine, right? Like from what I highlight here, that would fit. Like then you would have 2 millimeters left. So it would, yeah, more or less be doable. But my problem is you need an extra screws because I don't have any screws at the moment in the build you can use to mount that. So you would need a separate like M2 screw basically just to mount that switch. And that's the problem. So I try to limit like the screw selection a lot because like if you every type of screw you buy will be like 2-3 euros. And like in the very tight budget it makes a huge difference. So I think that this is still the best way because this allows us to use the same M3 hardware we already have to mount it. That's my thinking. And your solution is way prettier. Don't get me wrong. And I think it's a better solution if we would not have the problem with the hardware. The only other thing I see right now, we didn't consider this like solder pins here. So I would stick with that for now. But I like your solution more. Don't get me wrong. I think we need to add a little cutout here. Something like that, and then we say this to that. I don't know, let's say 1.2. And this to that is, yeah, 3 should be fine. And then we mirror this. And then here where we extrude that, we need to extrude this section. So there's like those solder thingies that need a bit of space. Just move it forward. And then maybe we can even add like a bit of chamfer here. Maybe like this. Okay. Then now I am confident that it will do something. And the things like technically we can also move that further in, right? Like later, if we decide like we need it further in, we can move this whole section just for, oh no, we can't because it's, here's the thick part, and then, I mean, it would fit, but could work. Okay. Then let's quickly export what we have. And then in our slicer of choice, let's send this is the smaller part of the two. And this we need not to print this way. Okay, let's slice that. Last check. Oh, this is, yeah, that's not a problem, right? Like this is quite a stretch to bridge. The rest is all fine, I think. Let's fix this quickly here in the middle. No, I think the cantilever, it refers to this section here. I think that's a problem. But it's an easy fix because we actually removed that. It's this little tiny thing here. May the fusion gods be kind to us. Yes, they are. And then the other thing is that this part we now need to flip 180. I have this export script, so I always like specify the orientation already in Fusion. And then when it poops out the parts, and I import them to Orca once, I can just say right click, reload from disk. No, but it didn't rotate it correctly. Okay. Everything's laggy today, like something's off with my machine. It doesn't matter, something like this. Slice. No, it still complains. Oh, but now it's... Oh. No. This is not good. This is not how we want to print it. It's also like... Oh. Why is it so screwed up? Wait. Let me quickly pull this back in. Is it this one? No, it's not this one. It's this one. I think the auto rotate thingy. That's weird stuff. Okay, yeah, but this is the orientation actually we want to print it, right? We want to print it upright. Let's slice again. Yeah, now it's fine. Okay, so the rotation was just weird. Now we have this like little wall here in the middle. Not sure if I showed the right thing. Yeah. So long bridge is gone. Okay, let's give this a shot. Print, upload and print. I quickly do this in the background. I just open like a new window of Orca and print the other part on the other printer. And as we speak, I realize I screwed up. Because this is... because this is ABS. We need to print this in ABS. Let me quickly emergency stop that. Restart. And hit print again. Okay. Oh, that's what we meant with not playing it too bad. Yeah, sorry. Sorry, I didn't get that. Let me quickly check the other printer that had an issue with homing. For some reason, like sometimes it doesn't home Y properly. Okay, let me quickly check that. I'm right back. Okay, the magnetic pad wasn't centered and like it hit the vertical while homing. No, it's fine. Okay. Then it's printing. While it's printing, let's just check the XY joint. I didn't expect us to take so long to design this like part. So this is the X, Y, or like the Y axis as we have it. So I quick shot it in the beginning, last week. 1 second. Last week we designed this part here, and I worked on this like during the week a bit. So firstly, originally wanted to have 2 rods for the Y-axis. We will still have 2, but only one will go through the bearing. So the other one will be either below or above. Let's figure that out later. The reason is like with this setup, we would have 4 rods that need to be perfectly parallel, right? Like if they're not perfectly parallel, then it will like bind up basically when you move it. Now we just half that to only 2 have to be perfectly parallel without impacting the movement. Then for X, basically consequence was from the top-bottom orientation. We now just went to like the orientation we just looked at in Fusion the entire time, right? These are 2 bearings that are basically the ones we are modeled around. The other part is actually, like now that we have this part here, I can actually show it to you. If this would have been here on top, you see that the bottom rod, or like the X rod here, would have been basically around or beneath the print surface. So that would have been like really problematic. That's why this setup is like way better, because then we don't have anything flying around here that's in the way. Okay, I also just realized I forgot to get the parts. Let me quickly do it as well, and then we can put up the final version. Like these are like beta versions basically. This one we will keep around for now. It's like close to final, but this one we will replace. 1 second, let me quickly grab the parts. Okay. So we have lots of rollers. Oh. Ah, okay. I also want to show something else. 1 second. I'm not even putting on to be right back. I also made this. Like this is just like some thing, but like I made this jig here. Basically that allows me just to cut like the perfect length for those like little like stacks. So basically I just put in the rod, cut, and then it's like the proper amount. And then here basically this goes through, so we can use this like later to like cut the rods very easily. This will also be part of the files if I release them eventually. You know, then I can just cut them nicely. So, these are the parts. Actually, we also, yeah, this one doesn't have a bearing inside, so we need to take this apart as well. I'm really curious to see whether this now all fits together. Also, I guess a quick side note. So basically last week we had like all the problems here with the parts splitting, right? And we tried like different print orientations, like the vertical didn't work. What worked in like vertical didn't work, it split like this. This one splits, yeah, like this. Like it split in all different like ways and orientations. So what I ended up doing is I printed it in 45-degree angles. If you can see that, like this is going this direction and this one goes this direction. So I basically printed here on this like surface on this surface. And that makes it seemingly okay. So just checking the print. So basically now the entire part is designed around being printed in this like in this orientation. So everything's overhang, which is a bit a shame. Okay, now all printers start at the same time. Okay, that looks good. You look good. Everything looks good. Let me. Here, you get the V0. And that's the switch wire. But the V0 has a bit nicer image, so you get this one. Okay, yeah, so basically everything is printed like on angle. And then we have the two indentations here, and on top the matching things, and that's where the stacks basically fit in. And then of course here goes the bearing. And the green part comes on top. Bit of a tight fit, and then it snaps together, and yeah, there's of course second one, and then there's like this little post here stabilizing everything. So that's kind of like the part I ended up with. But there's like one very important question, and that's a color scheme. Like at the moment I'm printing everything like in random as colorful PLA. So actually, like quick vote for the people who are here. What color scheme would you like to see? Like what I thought about was like printing a lot of black, but I still like using this like blue for accent. And this is kind of like how it would look, right? Like the black part and then the little baby blue accent. Is it like, do you like that, or would you prefer the green, yellow? Or like I kind of also like this like goofy like color mix, to be honest, because it's kind of like a bit of a goofy printer, so maybe like just have a bit of a goofy color scheme would be nice. Let me know what you think. Cool, but in the meantime, let's put that together. This doesn't look like it works. Give me a second to check that. Okay, it's a bit close to the bed, that's why it looks a bit funky, but should be fine. Like, I don't care about those parts. Like, we'll print them like 15 times anyways. Black and blue looks good. The goofy is nice, but if you need ABS black plus accent might be easier. I like blue's accent, but I'm a bit biased because Warren also have blue accent parts. Well, here's the thing, like I have a yellow, I have a red, so I need a new color. Like, that's why I was blue, and I kind of like this like black to baby blue accent. The only problem is this is PLA. I don't really care for this printer because it won't be enclosed at all, so I'm fine with having the. Kind of want to look on the switch wire a bit. I don't trust it right now. So I kind of like don't mind having that as PLA. Blue and teal. Oh, it's also like amazing combination. But then like I think like I would stick with that combo. Like I kind of like that. Let's see. So I guess let's just put the heat insert in first. I mean, before doing that, there's not much I can do. And I'm actually running out of heat inserts. I need to order new ones. I totally forgot. That's a side story. Like, I mentioned it briefly before, but I have like a major what the fuck moment. Yesterday. I was trying to make my switch wire print faster. Like I was trying everything. I was trying like configuration changes, like increasing the acceleration in the configuration, and like changing the speeds, and it just would not go faster. Like it was just like very slow. And after a little bit of like try and error and searching, I noticed that Orca Slicer like overrides the acceleration settings you set in the Clipper config. Like whatever you set in the Clipper config, it doesn't matter if you use Orca Slicer, it just sets the maximum acceleration via G-code. And I never bothered to like update the machine limits in Orca, of course, because like it doesn't have any impact besides like calculation of time, I thought. But yeah, like basically whatever you set in Orca dictates the speed of your print. That was quite a revelation to me. And it affected both my V0 and my switch wire. Like the V0 was stuck at 1,500 millimeters squared per second. Millimeters per second squared. And the switch wire was 500. That's why it was so dramatically slow. Now, like I changed it in the Orca config, and now I have like tremendously fast printers suddenly. It's amazing. Okay, let's put in the stack. We don't have a stack on the other side yet. So basically the stacks just need to be mirrored. Like, so each side needs one on, we have like the rollers, and we have the spacers. And each side, left and right, needs to have one of each top-bottom combination. So roller top, spacer top, but then they need to be in the opposite positions. So we take this. So here's the roller on top, and here's the roller on the bottom. It's a bit hard to see with all the black stuff again. See, that's a benefit of goofy colors. Like goofy colors on stream is much easier to see than the black. No. And we put the bearing inside. And then we need lots of M3 by 12. Oh, black and teal. Black and teal is also cool. Like, I feel like black is like a really cool base color, and then like there's so many like different accent ways, and they're all like kind of unique and cool in their own way. Yeah, that's by the way why I increased the hole diameter a bit. Like some holes were really sticky. So I don't think we need to over tighten this. As long as like the bearing is like properly put in place, everything is good. I don't like how the print from the switch wire looks. Like it will be fine, but it might be like a really ugly print. I don't know why. Yeah, as long as like the bearing doesn't like wiggle or something, I think we're super fine. Cool. Then let's actually like remove this one. Oh, and also like this grip's now really strong. Like in the last three we had like the rods for the x-axis wiggle a bit, but that's not the case anymore at all. Like it's like really solid. And I use like the longer screws now. How to do it the best. Yeah, let's actually just put this in place first. And then we can have this loose and just put it on top. But let's also add this one here. Use this one. I'm actually not sure if this is needed, like this like extra part here. Oh, it's the wrong one. It's a 20 millimeter, but we need a 25. Not sure if this is needed. Like because like the only tension those two get are like lateral, so I don't think that this helps a lot. Like it makes it much more stable, but I think it's okay, but most likely not strictly needed. So let's try to fill this one in. Okay, that's all the way in. I actually don't think you need to tension those like tremendously. Yep, no splits, and this is like really like a really solid connection. Okay, let's also put the roll stack on the other side. This one is like a slightly older variation on the design. Like you see, there's like this like screw goes from the back instead of like bottom and back instead of only bottom, and dimensions are a little bit different around the bearing mounts, but nothing really of consequence. So for now, it's fine. The 45-degree print trick is super nice. Yeah, it worked really well. Like, it just like spreads the load in like two different like axes, basically. It's not quite sure why I didn't think of that before. The only thing is like now here, like because the outer parts also print in 45-degree, which technically wouldn't need to, but like it's the best orientation now. This part here, you see here, it broke. So that's why I also wanted to have this extra screw here, just like to stabilize it a bit more. Where do we need? Yeah, now we need to remove a lot of screws here. So yeah, so this one is a prototype version still. But yeah, it's for now, like, I just want to put the printer together. I'm pretty sure that like at some point we will need to reprint that because we didn't consider X, Y, Z, and then yeah. The good thing is, I print most of the parts in PLA at the moment, and the company I buy all my filament from, Form Futura, they started the recycling program for PLA. So I feel half as bad printing all the prototype parts because I at least can send the material in and they will recycle it. Like they I'm not sure if they like add it to their like usual filament or if they make like a only recycled material filament line. I think it's a quite cool thing. Like you don't get anything for it. That's the only bummer. Like you don't get a voucher or something if you send the material. It would be nice if you send like 1 kilogram of material, you get like 100 grams for free or something like that. But I guess like processing the recycled material already costs more than just like buying fresh virgin material. Yeah, we need to be really careful with inserting this here because it's really tight. And the part is a bit fragile, so. Here we go. And then last one. I really want to try this part, but I want with just friction fitting some of the rods. I bet it would actually work for some of them. Yeah, I'm pretty sure that that would work totally. Like for me, I just have the opportunity here to clamp them. Because we have to kind of put this like bearing inside anyways, right? And at this point, like you already have like a part that's like 2 halves. And then like just having them here, it's just like an opportunity, right? Just, yeah. So those bearings, like I printed them, they are quite stiff for the first 60 seconds of use. I assume there are like some like bits and stuff inside that just needs to be like removed by moving it over the rod. But like after 60 seconds, they're like really smooth. So I'm just hoping that they're not wearing out further over time. That would be like a bummer. But also like for the bearings, technically like I saw like a lot of designs that just like clamp them basically in place. Like they don't even use screws, they just have like printed parts like wrap around them and just like, yeah, not friction fit, but like a snap fit basically. I'm pretty sure it's fine, like because like the bearings, all you need is like you need to restrict them like in their like XYZ movement. They don't have to be like super sturdy, I guess. Like the print quality of the switch wire looks horrible. I think the material is wet. I also hear some popping, so I'm pretty sure the material is like super wet. I only had 2 black spools, so the switch wire got the old one. So I'm pretty sure this is not okay. Okay. Let's put those back. Also quickly check then like what the current ETA is. But that's our part in goofy color. But it's like my concern is like we will find out in a second. It's like what happens if we constrain those 2 bearings, like if we bind them together, if it will still like smoothly go up and down, or if we if the rods are not straight enough or not parallel enough. Like I'm pretty sure like from the mounting they are super parallel. By the way, like this is super sturdy now, especially if you have like 2 more rods here. Like the only movement you get out of it is like rotation a bit, but it's quite hard. But as soon as you have rods through here, like rotating isn't the option anymore, and like you can't even pull it apart. Like the grip here is really strong now. Because somebody suggested like last time whether we want to drill through them. I totally think that's not necessary. Like they're clamped in place so well. It's an amazing picture toy. So I'm pretty sure that you don't even need the purchase bearing. Let's see. Okay, so that's put together. We still have some time to bridge. Switch wire is half done. Woron 0 is 2/3 done. Let me see. This needs... The switch wire needs 10 minutes and the V0 needs 7 minutes. Yeah, you can watch TV0 for a bit. Like this is, I'm so amazed. Like since I now fixed my Orca settings, like it's like it was fast before, but it's like way faster now. Okay. In the meantime, so I was showing this, but this is actually like garbage part because stupidly enough I printed the wrong part. Like this one has a M6 on top, which technically would work, but the hot end comes with the M10 here. There's an M6 in the pack actually, but I could have made it work, but like the easier one is the M10. So let's not make it difficult for everyone. Just I printed the wrong part. Like this is like for the extruder side. It's the M6 fitting. But this comes all in one. Like I'm still amazed how you can sell this for like €4. It's entire hot end assembly plus this €4. But let's do a quick test fit. Like I kind of know it fits because I kind of did it, but I want to show. So this is the mounting system for the Dragonfly something, but they borrowed the spacing for the mounting holes from the Creality hot ends, so you can use it for the Creality hot ends. That's the same tool head, the only difference is the fitting on top is M10 here and M6 here. I kind of want to make something out of this, like maybe like shelf piece. Like it kind of looks nice, you know. Maybe I add a fan and an LED or something and put it in the shelf. But yeah, so there's one bummer with this setup here, and that's something like I now mentioned like a couple of times. I really want to restrict how many different types of screws I use. The problem is for this one we need 16mm screws, which I don't have in the build so far. So to mount this you need two 16mm screws. And then actually for this part, which we just printed, right, and worked on, you also need a 16mm screw for this section here. We can shorten this distance here, of course, to make it 12. So this is not a big deal. Actually, let's quickly check. Yeah, this all fits. Yeah, it all fits well. Perfect. So this one we can fix, but here there's no way to use shorter screws. Because this is like just standing out like 4 or 5mm. And then even bigger bummer, to put this together, you need the really long screws here from front to back. And these are 35mm. So that's kind of a bummer. So I'm not certain what to make of this, because basically now to put the printer together, right, you need a couple 35s, like two 35s, at least two 16s, then tons and tons of 12s, because that's the screw I use everywhere now, and you actually need a couple of 25s. So we are already at 4 different screw types for the build, which is not ideal. Because basically, like, my idea was like you buy just a pack of 50 of each size and you're good. Or maybe like for 12 you need 100, and then the pack is like €3 or something. But now you need already 4 packs. And for some reason, like, I don't know if it's me, but I bought this like a while ago, and it's just like a collection of all different M3 screw types, like lengths with socket heads. I don't find that on AliExpress to put on my link list. It's kind of a shame because like it has everything you need, your nuts and everything, and there's enough screws of every size. Like these are like refills, the lighter ones. The only thing you would need to buy extra is like a lot of those like M3 by 12 because I use them just everywhere. But for some reason, like I don't find that. It's really weird. But yeah, that's a bit of a bummer that you use like that we need 4 different screw types. And I'm not quite sure if there's anything I can do to make that better. Maybe for like the super low cost variant, the sub €100, that means we need to offer a different print tool head. Oh, actually, this needs to go the other way around. Wrong one. Okay. And then basically this just goes in here. It's just first for the fan. I don't have the side fans yet. It's such a shame, like they arrive tomorrow. It's like they were like in shipping for I don't know how many weeks, and now they arrive tomorrow, and today I would need them. Like almost, but not quite. Nope. Oh, now we have like an extra antenna fitting. So now basically you take the long screws. They go through. And then we have to feed like the bottom tube all the way. And that would be our tool head then. Like it looks quite good actually. Like once you have like the blue accent on, like I think this is quite a sexy tool head for such a low cost printer. Now just to, I kind of want to assemble that later a bit. So let's put in the heated inserts in those parts. I mean, a manual would be helpful. Oh wait, we use nuts here. This part is completely free of heated inserts, so it's only here on the back. That's the only heated insert. And here we use 2 M3 nuts. See, it's like an extra item again. Like these are the only nuts so far in the entire build. It's quite tough to push in. Let me actually use a screwdriver, not my tweezers. Here we go. Okay. It's actually something like we can also use in a print or like in a build, like those like nut pockets. Okay, let's quickly give this again like a half second to cool down. I always put it off the build plate Yeah, this will look really horrible. The switch wire part will look horrible. But yeah, if it fits, it fits. Let me actually curl the cable. Just put it in here for now. Oh, and I will totally add LEDs to the tool head, just because I have some laying around. Just because the printer is cheap, doesn't mean it has to look cheap. But I'm actually like, the longer I work on this, like in the beginning, I was just like thinking this would be like some trash project. Like, you know, like you just build something, it's for the process of building it, but not for the end result. But the longer I build, or like think about this project and work on it, the more I kind of want it to be like a proper printer. Like, I kind of mentioned it before, but so with those motors, like this is like really the weak spot of the entire printer, I think. So what I want to do is, so firstly, I kind of want to see how far can we push those. So, but also I want to be able later to swap in like proper motors. So I think we will design the mounts for those in a way that they can accept the 28 BYJ48 motors here, but also normal NEMA 17 motors. Not NEMA 14 like the V0, because they're a bit more expensive, but just NEMA 17. And then like the interesting part would be what happens if we actively cool those 5-volt motors. Like if we add like a heatsink on the back and fans, like how far can we push those? So I think that would be like the step one is like, let's just build it with those like stock. And then I kind of want to tune those and see like how far we can push them. And then like as a third step, let's just throw in NEMA 17 steppers. I kind of low-key consider changing my switch wire from Bowden to direct drive. And that would give me 2 NEMA 17 steppers. And I also have like another NEMA 17 stepper lying around. Like they are all three the exact same. So we have A, B, and Z. So we can technically convert this machine into NEMA 17 with like proper steppers. And then at this point, we can also swap out this tool head for like a proper mini self-burner with direct drive. And then you have like a really capable machine actually. And it's kind of like the fun part of this machine. Like I tried to build it really like adaptable and scalable. Let me get this part. Half as bad. Like on the camera, it looked really crappy. I mean, the surface is really weird. Don't ask me what's that. You see that? Like, it's really like, but I think it's just a really just wet filament for some reason. But overall, like it's kind of strong. Like I'm not gonna break it, but this is doable. Yeah, I was way too close to the bed though, like way too close. Yeah, whatever. Prototype part, I don't care. So we need 2 heated inserts here. Let's also see if we can get this part. Let's see. So we need 2 heated inserts here, 2 heated inserts here. Oh, and 2 here in those really ugly holes. Oof. These are all the heated inserts I have left. I got my salary today, so I can order more now. I have enough money to afford more heated inserts. So, smart as I am, I turned off the soldering iron. Heat it up again. Or you can also like take this. Let's actually really take this apart while the soldering iron is heating up. Right. And this can go for recycling. And here we have to, it's actually good to pop them out just on the fly. Direct transfer. You kind of smell German, Nefni? You might be correct. You might be correct. It's like a heart transplant. Last one. Now there's a little bit of blue everywhere, but that's prototyping parts, so I don't care. I think we have everything we need to put the tool head together. Take those precious parts away. So kind of works. There's a tiny bit of binding here, but not really a lot. Let's see how it is when we put it together. Wait. This is a lot tighter than I expected or I wanted it to be, so we definitely have to add more tolerances. Like, this is like you're snapping together. That was not the plan. We'll take it. So we use the 25s in the front, right? I quickly have to drill out those holes, like they're a bit too tight. Let me quickly grab a drill. I'm right back. So, yeah, it's because it was so close to the bed, like all the holes are a bit closed up. So, Okay, let's put on the back ones first. I'm not quite sure why it's so tight. Did not expect that in slightest. Let's also put the board here already. And we have to add a little bit more stuff here. It's a little bit like wiggly, which is not really what we want from an end-stop switch, right? Yeah, and that's what I meant. Like, we have to work a little bit here on this part, like, because now we are like below the part. But I think technically it's like already quite okay distance, most likely. That's, I mean, we can try it out now, right? In like a second we see, but yeah, like working on this part here, just making it a little bit like L shaped, like it's not a big deal. So that's really easy. Okay, then we put this part on top. It somewhat starts looking like a printer, to be honest. It's definitely something we need to work on a bit. Okay. Let's also put in the one from the back, although we don't need it. Just for completeness. Yeah, doesn't want to go in. Yeah, no. Okay, here we are. It's the x-axis. So, I mean, technically works. The only thing that's a bit problematic is it's quite deep. So we lose some space here. But I don't see how we can make this much less steep. The X-end stop needs to be moved in like a little bit, but not too much. But we can freely reposition this hole, right? Like to just move it back like 5 millimeters. so that it kind of aligns with the side of the tool head here. So the moment, like the moment when this would trigger, we are still like half a centimeter away from, you see like here the gap between the Allen wrench. That's basically how much space we waste. So this can be moved in like 3-4 millimeters. Like here, just the board like moved back a bit, and then this would be fine. The main concern I still have is like the movement. So it moves, but it's not super smooth. Like you see, like there's like some binding. I think part of it has to do with the bearings being too tightly constrained. I wonder whether we should just make things a bit simpler. Yeah, Jonas, I was just about to do that, like remove one of the bearings. I'm also thinking something else. Like for some reason I had in my mind to like enclose the bearings. To like build it basically like as we build it now. I kind of had it in my mind from the beginning. And I think it's a simple setup, but or like the most obvious setup. Let's put it like this. But I think it's not the best. Because A, it costs us a lot of like that room, Y room. The tool head is quite far out. Yeah, like, see, like, it's really like... let's just move one to the side. Let me just... I mean, technically we don't even need screws. Yeah, see? Heide Dank. So it's really like having the two bearings. But we need two bearings, of course, because otherwise it rotates. But here's what I think. I don't think we need to restrain, or like we need to couple those bearings as tightly. What I was thinking just now is maybe we can simplify it in a certain way. Because at the moment, like we have the bearings in the center here, right? Like the bearings are super tight. I'm not quite sure why. But do we need this front section here at all? I would argue no. What if we just let the bearing here like be free, not free, but like in the end it comes down to the exact distance of those rods, right? Like the exact distance between the two. And in Fusion we don't have any tolerance there basically because of the clamping mechanism here. But in reality, like there will be a little bit of tolerance. Or like the gap between them won't be like 16 millimeters, right? It's like ever so slightly more. One of the bearings to move left, right. Yeah, exactly, that's what I mean. Like basically, I would like only restrain one bearing in the way we have it. And the other one, I would just make a half enclosed, right? I would just remove this entire front section here. Like just get rid of all of the front section. That it can move back and forth a bit. Like we can get rid of this like small teeny tiny wall in the middle maybe. If we get rid of this wall, then basically it also has a millimeter to the back. Because then basically we don't couple them like in the Y direction basically. I mean, X direction doesn't matter, right? Because they can freely move in X, so we can restrict them very tightly in X. Z doesn't matter either, right? Because if Z is different, it would just mean the tool head tilts back and forth. So I think what really is the problem here is the distance between the two. That if they are too tightly like coupled, yeah, that's also like it mainly gets hard to the end, where I think the distance in the center is like ever so slightly more than on the sides. But even just having it like this is already way better, like if it's not. Yeah, this makes it much harder. Can you check with the caliper so distance is equal between the rods? Yes, I can. Let's just check here on the side. I'm just gonna do it like this, like I put the calipers on top and then squeeze, because then we have the same angle. So here it's 2317. Oh, I moved the calipers and hit the 0 button. It's kind of like a natural end stop. So on this side it's 2314. 2323. 2344. 2325. Yeah, 2325. 2320. Hey, I'm not good at measuring that. $23.20. I think the distance is quite okay. The problem is like if I put too much pressure, I push them together. Yeah, 23, 25. This is pretty good. So right now I measure 23.23. In the middle it's 23.21. Ah, see now here's 23.20. Like you really have to be straight. Yeah. I'm pretty sure the distance is almost perfect, actually. I almost shocked how good it is. Try the inner distance. Can also 830. 814. 816. So according to that, yeah, in the center it's like ever so slightly more, like 0. 0.15. Yeah, 0.15 in the middle more. What happens if we push them apart? No, it doesn't matter. The ends are important. Well, the ends are identical. It's 816. 813. So 0.03 difference, which I think is as good as it gets. Loosen up the clamps just for testing. Yeah, can do. Yeah, it's still like when it comes to the end, it tightens up. Do you have some real bearings testing? No, they're still in the mail. Should get them next week. Are you here in the center? It's perfect. But I wonder, like, if I would print the parts again with like a higher tolerance, not higher, like with a bigger tolerance. Where that would help. Because like the bearings are just like, even if like I put it in here, like it's just too tight, I feel. Although like, that's the thing, like with one open, like if it's just like this, like they're already clipped in, right? They're like kind of like restrained. This is way better. This is way better. Like there's a bit of resistance towards the end here, but that's it. And as soon as I put the other half on top, it becomes way stiffer in the end. Then it's really that the carriage is just a bit too far apart. Yeah, I think so. I mean, it's also like in the middle, right? The rods are a bit bendy, like you can bend them. So I think that the carriage is just pushing the rods, the bearings apart. Or like in the middle, the carriage can push the rod apart a bit. But on the end, it doesn't, because like they're like mounted here. So I think that's the problem. So what I think would be the solution is to not restrict one of the two in the X or in the Y direction, like in this direction, to just leave it open. And then if you assemble it on the side. And then basically like one is restrained and the other one can freely adjust freely. There's a bit of like there's a limit to the back, of course, because I put them super close together, which I kind of regret right now, but maybe I can just space them out like a millimeter more. And then you put it here, you assemble it, and then this should be not the issue. Like in the center again, like there's flex, you can even see it, right? Like there's definitely like flex in the rods, like you can flex them a bit. So in the center, I'm not concerned. As long as they're like properly spaced on the side, that's good. And then again, like the X is then free. That doesn't matter because just like worst case, you tilt the printhead a bit, right? If it's like off in Z. And X doesn't matter because like you move it. So then I think this is really solving the problem. Making one free is the way to go. Yeah, definitely. You do not even need to open it up. A few millimeters should be enough. Yeah, like even a millimeter would be most likely fine. But here's what I think about opening it up completely. So if we put this back together and like we assume happy world, right? Like this works perfectly. This is like quite a big part. So if we would not enclose it fully, and by not enclosing it fully, basically I mean like just cut it off here in the center more or less. Like not quite center, but like, you know, like at the end of the rod, we just saw it off basically. Then we save quite a bit of distance. Like if you look here on the back, right? We're now extending this part by a centimeter basically. Roughly 8 millimeters, yeah. That's like space you lose in depth, right? Like from the movement, because they can bottom out against the hind thingy, and then this would collide with something most likely. I mean, we didn't design the motor mounts yet, so maybe we can make a pocket. But you know what I mean, right? So cutting this off would be nicer. That would also mean then the switch moves a bit forward. So I think that would be a good thing to just like leave either the hind one open. I mean, technically would like feeling this. I wonder whether we need like, if 2 screws are not enough to clamp that together. Because if you would leave it open on front and back, let me quickly take that apart. I mean, at the moment that we are here, right? If we... It's kind of like, here's what I'm thinking. So we screw into those nuts here, right? What if instead of the nuts, we screw directly into that material here? Now you put a heat insert here and here. And instead of 35, we need 40 millimeter screws, but it doesn't really matter, right? Because there's nothing stopping us. No, but that doesn't help us, actually. That doesn't help us. Because like if we screw directly here, we can't remove the front part because there's then not enough space. Okay, but then the back part I would just cut off. And then for the PCB, we just mount it to the center. Somewhere here, center, whatever. But we also need to move the PCB back a bit, we said. I mean, looking at this, like if we move the... If we mount it to the center position, with this side here to the center hole where we have also like spacing, this would kind of neatly align with that back wall. Plus we can modify this part here, right? This one, the center one, on one side, to just have like a small wall here. That just has a small wall. And that wall can then be basically what this like homes against. Because then this would be somewhat here, I don't know. And then like we can home until here. And then we have like a couple millimeters left, which we will need anyways for the tool head, because the tool is a bit wider than this. And I think that's like quite good. Okay, but we lose the screws. No, yes, we would lose one pair of screws. Like the hind screws would be gone. But to be honest, I don't think we need them at all. Like if we have 4 screws tightly like wrapping the front bearing, and then just like this one, it's just like it will just be clamped, right? Like the parts are not that flexible that like on the couple of millimeters that we have distance here, they will like flex. So we have those. To be honest, like even only having 2 in the middle, I think will be enough, or would be enough. Like it wouldn't be super like sturdy. So I think 4. Those 4 is enough, and then this can just go, I think. No, sorry, this direction. Those 4 we need, and then those can go, and then we align nicely on the back. So it's like, I think only upsides. So I think that would be my go-to. There are 2 more in the middle, I forgot. Yeah, exactly, like we have 6 at the moment. The only thing in the middle, at the moment, the middle ones don't go through, but there's nothing stopping us, right? Like the heat inserts are at the moment at the top. We can just put them on the, like here in the middle. And then we use, at the moment we use 12 M3 screws here for the hind ones, but we can just use the long 25 ones like in the front. Then we have 25, 25, 25, 25. Right? And then this goes through, clamps in the middle, clamps in front, and then the back part is just gone. Okay, so knowing that those parts are kind of like garbage anyways, shall we just mod them quickly and try our like open approach? Let me grab a saw and we try it out. 6 is overkill. Yeah, but only 4 at the moment are putting the parts together. The 2 in the middle are only holding this part here. Let me quickly grab a saw and we just do some magic. We also save weight, yes. We do save weight. Let me make sure to not cut off the wrong side. Well, it doesn't really matter. How do I do that without losing fingers on stream? Can you use my... Okay, don't do it at home. No, definitely not. Let me actually just do the top side. The top side is easier. That should already be enough. Oh no, it isn't. We need both sides. But let's just do it the other way around. Problem is I can't really push it. Like, it's not quite reaching like the other side here. Man, this is a hack job. Okay, I don't think that is a good idea. Let's do it the good old way. Wait, let me actually, maybe this tries. These fingers are gone, yeah. Okay, that was the better idea. Okay. All fingers. I'm not a good role model. So. Uh-huh. That works well. Like, it's still not perfect around here. Still not perfect. Like, here it's perfect. Like, everything up to here. Here, like the last teeny tiny bit is not really good. But I think this is way better. Let's just, for testing, let's quickly punch some screws in. Yeah. At the moment we only can put in those two, but it's still much better. I wonder if we can somehow yeah, of course, like if we loosen those a bit, it's super easy. Oh, that fixed it. Ah, that fixed it. I don't know, like I just loosened it again, tightened it again. Easy. Like all the way at the end, like little tiny bit, but it's not like a big deal. Okay, then this is the design to go. To be honest, like it might just look like this, right? Like this half circle, and the bearing is just open at the back. Let me quickly put this on the other way because I kind of cut off the wrong side. Maybe good idea for instruction tightening with the carriage being there. Yeah, maybe. But I'm not quite sure why it works. I would make it a bit bigger. You still want to restrain that. Yeah, but I think we still do that, right? Like as soon as like goes over the center. No, you don't even have to. Right? Because it's like a circle, like even if you would have like only like quarter of the circle, you would still restrain that. And now it's a bit sticky again. Let me try my trick again. Yeah, that definitely like helps to adjust it in some way, shape, or form. Don't ask me how, but it helps. And also, like, keep in mind, this is like almost double the width that we will have in the end for the like the base version. Like this is enough for like the 200, 250 print bed. And we will only rock like a 120. Not sure about your plotter. But you can also maybe, I mean, that's also like a thing, right? These rods are were never meant to be used for something like that. They're just from the hardware store. So I'm not sure if they're like 1000% straight. So it might be better if you use like longer distances to use like proper smooth rods. But overall, I think this is a good design. Like it's also like the bearing's like barely shorter than, yeah, it's just like it lines super well. Like it's kind of like accidental, but like it lines like it's a millimeter of space. So if we then home later, we can home against, or like on the end position, we can really just move against those parts, and like the X carriage doesn't add any like Y depth we lose. Try twisting. Try twisting. Well, but like right now you can't twist them. That's actually something also like we didn't talk about, or like, but you have to push it down because you can't twist it. Because it's round, like you can kind of like twist it. But in the moment you put the Y axis in, or like the Y rods in here, you can't twist it anymore, right? Because like the rods prevent twisting motion on these two. But right now you can do this. Like you can totally do this. Oh, but maybe that was also the problem, like why it didn't, maybe we didn't push it down quite. The carriage you can't, like if you twist the carriage, it twists the entire axis. Like this is like quite broken now, so it has a bit of play there because like there's like yeah, I saw through that, so that is what it is. But I think like if this is like properly put apart, this should be fine. Yeah, okay. That's the design we go for, like with less less jankiness. But then basically for me, what I would do until next stream, just like as a heads up, I really want to do as much as possible on stream. But I feel like I need a little bit of focused fusion time to clean up some stuff. But I would design this exactly that way. Like I just cut off, like I clean up the fusion file and I would cut off this half end basically there. And I will like reposition the mount for the board. I will also give like the design from Kublik, I still don't know his name, I'm really sorry, another shot and see if we can integrate that. But now with the half thing gone, there's even less space. So let's see about that. But I'll check it out. But yeah, I think this is like a success. So this part can basically stay as is. The only thing we didn't work on yet, I have to reprint that. What we need to do is we need to shift, like the belts go here. So firstly, we need to check. That's another thing, right? We didn't, or I didn't think about that at all. The problem is the belts are restrained here and here. And if Zero uses those like fancy big nuts, but we don't have fancy big nuts available. So we need to find a way to restrain the belts in here. Let's see. Potentially what we can do. Yeah, I'll think of that. But I guess that would be it for today. It's already midnight for me, so time to wrap it up. It needs to align with the idols. Yeah, it doesn't yet. It's too high up. Like you see here, there's the belt is here, and it needs to be here. Like this needs to be quite a bit more down. But I figured that would be the case. Like the tool head sits a bit higher. I'm also wondering whether we can shave off like a bit of like material on top, just like 1.5 millimeters or something. Just like swell it down a bit. Let's see. But yeah, so let's see. Maybe I work on this on off stream. Maybe we wait and do it next stream. Let's see about that. But basically we still have to do the front idler and the motor mounts as well. So there's still plenty of work. But like this looks like a printer already a bit, so I'm happy. Cool. Thanks everything for tuning in. Thanks Jonas for the support and help. Or screw from the bottom. No, you can't screw it from the bottom because in case somebody wants to have a direct drive extruded, the motor goes up here. So if it's on the bottom, that collides with that thing. So it needs to be on top. Yeah, it's just a bit of different like layout. That's why the belts are much down, but I don't think it's a big deal to extend this part like 2-3 centimeters. Cool. Okay. I'm very happy that you contribute and think with me and protect my fingers. Cool. Okay, then see you next week. Enjoy your weekend.